Good morning, everyone, and welcome to the second edition of the astronomy workshop for enthusiasts. This is being conducted. This was conducted earlier also, but post-COVID, we have revamped and we are back with the second edition. And this is jointly organized by Department of Physics and Electronics of Jain University and also Bangalore Astronomical Society. And it's indeed a very long journey that the School of Sciences and Department of Physics has had collaboration with BAS. I think right from 2009 onwards, we have had sessions almost every year, and many of our students have been volunteers with BAS. I personally have been a part of BAS, of course, and eventually many students have also been part of the star parties that BAS organizes, and many of the BAS members are also very good friends of myself and involved in a lot of projects with the departments in the coming days as well. And it's indeed a happy moment to welcome all of you on the second edition and today. And I would like to welcome Dr. Sudhakar Reddy, the head of the Department of Physics and Electronics, and also all the members of BAS, and of course all the participants who have come across from different parts of the city to attend this one-day, full-day workshop on amateur astronomy. I'm sure this journey is going to be very engaging because I know the team members have spent quite a lot of time in preparing, rehearsing, having dry runs, multiple dry runs, in fact, and a lot of activities have been curated just for this workshop. So I'm sure this is going to be a wonderful learning occasion for all of us. I welcome all of you on behalf of Department of Physics and Jain University and also BAS kind of. And I would request Dr. Sudhakar Reddy to give opening remarks. And with that, we'll officially launch the workshop. And post that, I think Mr. Nandan from BAS will take over and he'll kind of steer what we are going to do, how we are going to do, what all is planned, complete details they'll be discussing with you guys. And we hope you have a good moment. Don't worry about your coffee, tea, food, everything. We have taken care of that. You will get good coffee, tea, snacks, and also good lunch. Let the session be only food for knowledge. So you can concentrate on that and make it as interactive as possible. Ask as many questions as possible. The team has prepared for that, I know. As many questions as possible. And eventually let the community grow and let us all come together so that we can individually build the community at our own capacity. With this, I request Dr. Sudhakar Reddy to welcome the gathering.
Good morning to all of you. It gives me immense pleasure to welcome all of you to this astronomy workshop organized by Department of Physics and Electronics in collaboration with in space science, with the technological advancements in space science and communication, astronomy plays a very vital role. At this juncture, I thank all the members of Bangalore Astronomical Society and their volunteers for collaborating with us in organizing this event. Astronomy is an interdisciplinary subject. It connects physics, maths, electronics, and computational sciences. Today, we have this workshop. Of course, it gives hands-on experience for all the participants here. I would like to thank Dr. Sundar M N, enthusiastic young faculty in our department. We always think of providing special learning experience for all the student community. And also I thank Dr. Shashank, who is also plays a key role in organizing this workshop here. I wish all the participants to have a great hands-on experience today. Thank you all.
ಚೆಕ್ ಮಾಡ್ಬೇಕಾ ಟೆಸ್ಟಿಂಗ್ ವರ್ಕ್ ಆಗ್ತಿದೆ
Keerthi, ಬಂತ ನೋಡು ಪವರ್. Is it working ನೋಡು? ಚಾರ್ಜ್ ಆಗ್ತಿದೆ. ಆಗ್ತಿದೆಲ್ವಾ? ಯಾವುದಿಲ್ಲ ಸ್ವಿಚ್ ಆನ್ ಮಾಡಿ.
ವಿಶ್ವ
ಲೈವ್ ಸ್ಟ್ರೀಮ್ ಮಾಡ್ತಾ ಇದ್ವಿ. ಸೊ ಯಾರು ನೋಡೋದಾದ್ರೆ ಯು ಕ್ಯಾನ್ ಗೋ ಟು BAS ವೆಬ್ಸೈಟ್, ಸಾರಿ BAS ಯೂಟ್ಯೂಬ್ ಚಾನಲ್. ಫ್ರಮ್ ದೇರ್ ಯು ಕ್ಯಾನ್ ಸಿ. ಓಕೆ. ಸೊ ಈ ಕಡೆ ನೀವು ಆ ಕಡೆ ಇನ್ಫಾರ್ಮ್.
ಅಷ್ಟೇ. ದಟ್ಸ್ ಫೈನ್. ನಿಮಗೆ ಇದು ಬೇಕಾ ಪವರ್ ಸಪ್ಲೈ? ಇದು ಎಕ್ಸ್ಟೆನ್ಷನ್ ಕಾರ್ಡ್ ಬೇಕಾ?
ಎಕ್ಸ್ಟೆನ್ಷನ್ ಕಾರ್ಡ್ ಆಮೇಲೆ
ದೊಡ್ಡದಿದೆ. Is on it. Yeah. Hello everybody, good morning. Thank you for the warm welcome, sir. My name is Nandan Narasimha. I am a part of Bangalore Astronomical Society. I work as a volunteer there, just like several of us that you see here. First of all, I'd like to welcome you to the second edition of Astronomy Workshop for Enthusiasts, or as we like to call it, AW 2024. We are very thrilled to have you here today. I know it's a Saturday, you could have been doing a number of other things, but you decided to join us, spend the day trying to learn more about astronomy, quite possibly one of the oldest sciences known to humankind. Before I proceed, I'd like to thank the Jain group of institutions, Jain University and the School of Sciences for giving us this platform, this opportunity to conduct this workshop here. Now about Bangalore Astronomical Society, or BAS as we call it. BAS is a non-profit organization, non-profit club, I'd like to call it club. I don't want to use the word organization. BAS is a non-profit club, astronomical club, founded, run and managed purely by volunteers. Volunteers who have this deep-seated passion for astronomy and the science behind it. That is our primary motto, to popularize astronomy. Now, BAS started sometime in July 2006, and now we are probably over 2,000 strong. And I'm very proud to say that BAS is probably the largest amateur astronomy club in India, and quite possibly the most active, based on the number of activities that we conduct. Speaking of activities that BAS conducts, I'll briefly touch upon some of the activities that we do. We regularly do something called outreach programs. Outreach is where we engage school kids, especially kids from smaller towns, villages, into astronomy. We take our telescopes there, we have astronomy activities, we look at the night sky, and it's a lot of fun actually. And we do this because we have this deep-seated belief that a small spark ignited somewhere in some young mind will probably go down, do something really nice, really great in future. That is about outreach activities. We do star parties. Star parties, believe me, they're legendary. Now, for those of you who do not know what a star party is, it's basically a get-together of people under dark skies, far away from city lights, to observe the night sky. We at BAS have access to some very pristine skies in South India, where we observe from. We can tell you more about that later on in the day. As the day progresses, we can talk about that. We also conduct workshops just like this. We have online talks, we have seminars, webinars, anything and everything that has to deal with astronomy. We also do, during major celestial events, like be it an eclipse, solar eclipse, lunar eclipse, or comet visits, we set up our telescopes in public parks, in public spaces. Sometimes we've done this on footpaths too, and we encourage people to look through telescopes. This improves engagement of general public into astronomy. Also, technologists as we are, one of our members also has developed an app called Sky Eye, which is, as we speak, is available on the Android ecosystem. Amateur telescope making is one of our other interests. Some of our members have built their own telescopes. I repeat, their own telescopes from scratch. You'll meet one of them later in the day today. So before I move ahead, I'll wait a minute for people to settle down. Oh good, the hall is filling up. All right. Before I move ahead, can I please get a show of hands of who's absolutely new to astronomy here? Wow. Okay. This is nice. This is heartwarming.
The director of the campus, Dr. Asha Raj.
I'd also like to welcome the director of Jain University, Dr. Asha. Thank you very much, ma'am, for coming down. So that is people who are absolutely new to astronomy. That's very nice to hear. I know a whole bunch of you are college students. Can I see a show of hands of college students, please? Jain and other colleges too. Okay. How about school students? Any school students? Okay. Okay. Very, very good. The reason I asked that question is we have something for everybody. I'll tell you about the program for the day today. We will start off with a basic introduction to astronomy. This will be like Astronomy 101. Then we'll follow it up with basics of visual astronomy. You'll start seeing the difference between the two in a while. Then we talk about, we have a demonstration using an app called Stellarium. We have a demonstration of how the night sky changes, with respect to time. So that's the reason why we asked you to install this app called Stellarium. If you still haven't done that, if you haven't installed Stellarium, please do it now. It's a free app available both on the iOS ecosystem and on Android. Please install Stellarium. After that, we have two activities running in parallel. Weather permitting, we will go outside, we will look at the sun. We have a few telescopes here. We will use one of those telescopes to look at the sun. That should be very interesting. This is, of course, weather permitting. If there are no clouds, we can do that. Parallelly, we will also be doing an activity, what we call the constellation activity. Post that, we will break for lunch. Between 12:30 to 1:30, we'll break for lunch, and at around 1:30, we will reconvene. We will talk about amateur telescope making. We will follow that up with a detailed talk about astrophotography. And then we will have a talk about a personal journey by a highly accomplished amateur astronomer on our who's very active member and one of the founders of BAS. He's going to talk about his almost 2-decade-long journey as an amateur astronomer. Once we're done with that, we will take your questions. We'll have a question and answer session. So please feel free to ask your questions. You can ask your questions at the end of each session if you wish, or during the QA session, or you can post it on the Telegram group that you joined soon after registration. So we leave it to you. Please go ahead, ask questions. Let us make this as interactive as possible. And yeah, that's about the plan for the day. So sit back, relax, and enjoy the event. And hopefully, oh yeah, we are going live. We are live streaming this event as we speak. The live streaming is available on our website, bas.org.in, through our YouTube channel. So if you have anybody who wants to watch it online, they can do that too. So sit back, relax, and enjoy the event. Now let me go ahead and invite Varun to talk about an introduction to astronomy. Varun does, during the day he does marketing, and at night he does star hopping. So that's Varun for you. Varun, it's all yours.
Hello everyone. Good morning and a very warm welcome to all of you. Thank you so much for spending the weekend with us. And it's probably born through our innate desire to know about the universe and ask and answer the big questions, which is where do we all come from? And where does this all lead to? Right? And if you look at it in a way, astronomy is the universe's way of understanding itself. And that is what differentiates us from other species. This innate curiosity and the thirst for knowledge that we have to understand the world around us. Can anybody tell me what this white band is? Anyone in the audience? Milky Way band. Perfect. Great. You guys are already more experienced than I am. So good to know. Since time immemorial, human beings have looked upon the night sky, gaze at it, and understand how everything works. Right? All these stars, all these clouds, this big white patch in the sky, all the galaxies, these tell a story which is billions of years in the making. And right now, if you go out at night in Bangalore, I bet you can't see more than 10, 15 stars, right? Can't see anything. It's too light polluted. But back in the day, there was no cars, there was no street lamps, there was nothing. And our ancestors had access to the most pristine skies the world has ever seen. So they were able to look back, look up, and see and trace the journey of these objects, these celestial objects, be it the stars, be it the planets, right? Year upon year, decade upon decade, they would capture, observe, and write down the movement of these celestial objects. Everything in the night sky, they would observe that it rises from the east and it sets in the west. Can anyone tell me why that is? Shall I repeat the question? When you look at the night sky, even the sun for that matter, it rises in the east and it sets in the west. And you'll notice a similar pattern whenever you look at the night objects, be it the moon, be it the stars, constellations, and whatever. Can anyone tell me why that is? Hands up, please, so I can just ask you guys once all. Anyone? Sorry? Earth's rotation, exactly. The Earth rotates from west to east, and that's why, relatively speaking, the night sky seems to move from east to west. Now, before I get into the details of astronomy, I wanted to show you one photo. This was taken by the Voyager 1 spacecraft on Valentine's Day in 1990. One of the, I think you should have it better. Right? One of the great astronomers of our times, Carl Sagan, he requested NASA to have the Voyager 1 turn around and take a shot of Earth. Do you see this dot? That's us. That's us from 6 billion kilometers. It's a mote of dust suspended in a moonbeam. Right? Everything that you know, all the wars, all sort of lectures, all workshops, the best filter coffee, everything is available only on this dot, as far as we know, right? And nowhere else. This is not exactly a great picture from technical point of view, right? It's very blurry. It's not very clear. You can barely make out the Earth here. But it shows the fragility of life and exactly where we are in the universe. It gives us a locus that this is all there is. And from this, we are now exploring the universe and trying to understand what it means. By the way, the Voyager 1 aircraft is now around, I believe, 14 billion miles away, 5 times farther than what it was when it took this photo. Right. So next, let me just give you a sense of where we are in the universe and attempt to explain the scale of this universe. Now, the numbers that we use when it comes to measuring distances in the universe are so huge that for the human mind, it is quite incomprehensible to understand these, right? But still, let us give it a shot. This is the solar system that we know of, right? Here is Earth, You can see the sun in the middle. This is not to scale. The solar system itself is so big that if I try to scale it here, it will probably extend from here to JP Nagar. Okay. But still you get a sense, right? You have all the inner planets, you have the outer planets, you have the sun, and you get a sense of this solar system. But the solar system is just one of these systems in our galaxy, which is called the Milky Way. The sun is just a star, and our galaxy is known to contain anywhere between 100 billion to 400 billion stars. And so, this of course is the Milky Way, a photo that I took when I was outside the Milky Way, right? And this is approximately where we are in the outer spiral arm of our galaxy, okay? But then Milky Way is not the only galaxy in this universe. This is something that we call the local group. So our galaxy, some of the dwarf galaxies that surround it, and then we have the Andromeda Galaxy, which is our neighbor. And after 4.5, 5 billion years, we are going to merge. But that's a topic for a different day. Right? The local group. Just a second, guys. Even though we have explored the universe, we have sent Voyager 1 so far, we still struggle to set up a presentation. So that's just the reality of life. Got it. Right. Welcome back, guys. We are live again. Okay. So this particular grouping, the Milky Way galaxy and the Andromeda galaxy and the surrounding dwarf galaxies, we call it our local group. Okay. This local group is again a part of the Virgo supercluster, as we call it, and again a very small part of that. The Virgo supercluster is again a part of something called the Lanakia supercluster, which is again a small part of that, and that is a small part of the observable universe. So just to give you a sense of where we are and how small we are when it comes to the size of the universe itself, it's really, really small. But still, we'll attempt to understand it to the best of our knowledge. Okay. Again, this is Astronomy 101. So we'll start with the very basics. And I'll not delve too deep into these topics because they are quite explanatory. But in case you have any questions at any time, please feel free to ask. Okay. In our solar system itself, we have what we call planets and moons, of course. Right? Planets primarily are into 4 different types. We have the inner planets, which we call the terrestrial planets. These are rocks composed of rocks and metals, which is basically Mercury, Earth, Venus, and Mars. We have the gas giants, right? Jupiter and Saturn. We have ice giants, which are Neptune and Uranus. These were earlier considered as gas giants, but upon reclassification, they have been reclassified as ice giants. And then we have dwarf planets. If you remember, we have now 8 planets, right? I think Pluto was bumped off the list in 2006. I, for one, was quite disappointed, but it is what the scientists say, right? Can't do much about it. That's, yes, exactly. The reason why it was started was as a protest, to protest against the ousting of Pluto. Right. Coming to the next structures in this universe. Nebulae, right? The word basically means cloud, and we have different kinds of nebulae. As and when we progress during the day, especially during the visual sessions and the astrophotography sessions, you will see much clearer, much beautiful images of these nebulae. By the way, these photos, they have been taken by BAS members themselves, right? So There you go. I will not delve too deep into the different kinds of nebulae out there, but just for understanding, the primary way of classification is the way the lights are created. Either they emit light, or they reflect it, or they block light from somewhere else, right? Okay. Then we have planetary nebulae, which are basically a shell of gas from a dying star. This planetary nebula that you see, it's a ring nebula, but probably after 5 billion years, our sun will also end up into a planetary nebula. And after a few more years, it will end up into a white dwarf. Right? That is the evolution of our sun as well. We'll look at it later on. The important thing to understand is how stars are distributed in this universe, right? They are either individual stars, which is very rare, but usually they are part of some sort of a cluster or some sort of a galaxy. Now, there are two primary types of clusters of stars. They are called the globular cluster and the open cluster. Right? A globular cluster, if you look at it from a telescope, it will look like a very fuzzy sphere. It will have a very dense core, and it contains a lot of stars, from thousands to millions of stars. All right. Another important feature of a globular cluster is that it is full of old stars, and very, very old stars. The open clusters, on the other hand, is primarily made up of younger stars. There's usually no distinct shape, right? And usually contains far less stars. But the common thing that unites both of these are that these stars are gravitationally bound to each other. Okay. This is a very popular open cluster. It's called the heart cluster. And you can barely see the shape of a heart if you use your imagination, right? Okay. A lot of things that we astronomers look at in the night sky, you have to be deeply imaginative to understand the shapes that see. There's a cluster that looks like a starfish. I hope the AP folks have those images for you guys, right? There's a cluster that looks like an electric guitar. Okay, and we come up with these very interesting names. Astronomy as a science is always known for keeping very interesting names. The origin of the universe, Big Bang, right? Things we don't know, dark matter, dark energy, right? So that's how it is. It's a very simple science, and hope you guys will enjoy it as we go on along the day. The next big thing, of course, is galaxies. Primarily, there are three types of galaxies: elliptical, spiral, which is the Milky Way galaxy, and an irregular galaxy, right? So an elliptical galaxy will be a bit of an ellipsoidal shape or a spherical shape. It will have a dense core, right? And mostly it will have older stars. This particular photo is from the galaxy called M87. It is also known to have a very, very, very massive black hole inside it. You remember a few years ago, a photo of black hole came out by scientists, right? It's there, somewhere there. Then we have spiral galaxies. Now these galaxies have spiral arms. You can see these arms here, right? Okay. This is a very famous spiral galaxy. It's called the Whirlpool galaxy, right? There are active star-forming regions in these galaxies. So if you see these reddish pinkish dots, right? These are very active star-forming regions in the galaxy itself. And then what we have are irregular galaxies. They don't have any definite shape, right? They may have some star formation areas, and this particular one, as you see it, it's called the whale galaxy. You see the whale shape, if you use imagination, and this is the hockey stick, right? An inverted hockey stick. Okay. We'll not go into details about how galaxies are formed, as it is beyond the scope of this workshop. But in case you have any questions during the break, catch hold of any BAS member, they will be able to help you out. Okay. Now, again, one of the most important facts that we often miss out upon, that at the end of the day, we are all stardust. Whenever a star is formed, and there are different life cycles that a star can go. This particular one, the bottom third one, this is the path of our star, which is Sun, right? The protostar, the Sun forms, it goes into a red giant, a planetary nebula, and then a white dwarf. Okay, and then there are different kinds of other journeys that a star can take. A star is born, it lives its life, and it dies, just like us, right? And every single element that is present in a human body was once a part of a stellar nursery. That's where we came from. Right? Now, when you look up at the night sky, probably on a very good night and probably on the upper Himalayas or somewhere dark, you probably see stars like these, right? A very clear blinking stars. Back in the day, our ancestors, they would connect the dots and create a story out of it. So they connected the dots and they started seeing shapes in the night sky. And using those shapes, they started telling stories so that wisdom and knowledge can be passed from generation to generation. This is a very famous constellation called Orion, and it's very prominently visible even from Bangalore, by the way. Right? Any Harry Potter fans here? Few of you? Yeah. So this star is called Bellatrix. This star is Sirius, right? So J.K. Rowling was also an amateur astronomer. We believe, we have not confirmed it yet. Okay. And there are very interesting stories around these characters, especially in Indian mythology, in Greek mythology, and so across the world. This belt of stars that you see, in astronomy, they have Arabic names. I think this is called the Alnitak. The second one, the middle one is called Alnilam, and this is called Mintaka. But in Hindi, in Sanskrit actually, these are called Usha, Anirudh, and Chitralekha, the characters of Mahabharata. There's a very famous celestial dance, a celestial hunt that happens around Orion. You see this torus? Once you have the Stellarium session, you will witness this, that this looks like a bull. Its two horns, his head here, there's a bull here. This is Orion is a hunter. You can see a basic human skeleton holding a bow and an axe, right, fighting the bull. And it is followed by his dog, Canis Major. Okay, right? One of the stories goes like Orion was bitten by a scorpion and that killed him. So Orion only rises in the night sky once Scorpion sets. Scorpion is another constellation. It's not here in this photo, but going forward, maybe somebody will show you that. So you'll notice and observe that once Scorpius sets, it's only then that Orion rises. And while this is a very important scientific fact, it was passed down from generation to generation from a simple story that the Orion can only come when the Scorpion is not there, right? So all these stories, they have some kernel of truth, and it would be very interesting to revise those stories, to go back to them and understand the truth that exists in them, and then correlate it with modern findings. The other thing is, when you saw these constellations, these stars are not usually in the same plane, right? These stars, as observed from Earth, they can be relatively spaced between them. But since we are seeing them from so far away, it looks like they form a particular shape. Can anyone identify this constellation? Can anyone identify this constellation? Saptarishi, right? It's a Saptarishi, exactly, Big Dipper. Okay. Again, there's a very good story about these two stars there, right? If there are any South Indian folks here, there's a story that goes as Arundhati and Vashisht, right? Married couples are made to look at these two binary stars and figure it out, right? Yeah. Almost to the end of my session, guys. Just bear for another 5 minutes. Back in 1995, do you know what this is? Anyone? Hubble telescope. Perfect. Spot on. You guys said you're all amateurs, no? How do you know all this? Something is going on here. Okay. Right. So the Hubble telescope, the folks at NASA, they decided to point it at one spot above the Saptarishi. Okay. At one spot. From Earth, this spot had nothing. We couldn't see anything there. And this spot is as big as a pinhead. If you hold a pinhead to the night sky, that's the space that it takes in the night sky. Okay. So it went here for 10 days from, I believe, December 18th to 28th, 1995. It took 342 photos of this particular spot. Right? These photos were of long exposures from 15 minutes to 40 minutes each. And this was the result. Two questions here. Can anyone guess the number of stars in this photo? Anyone? 20,000? Right. So there are around 20 or so stars in this photo. Everything else that you see is a galaxy itself. Anyone can guess how many galaxies are there in this photo? Rough count, anyone? 3? Any guesses, guys? The one who guesses right gets 2 copies free. 100? How much? 10,000? What we know of, there are approximately 3,000 galaxies in this particular frame, in a patch of sky as big as a pinhead. Right? This was the first idea that we had from the Hubble telescope, that how big the universe is. This particular image is called the Hubble Deep Field, and there have been multiple deep fields since then. It gives you a scale of how deep the universe is. The oldest galaxy in this particular one is around 12 billion light years from us. Light year, another concept. Anyone knows what a light year is? One person, please, hands up, and I'll ask them. Yes, please, ma'am. Exactly. So in 1 year, the distance that light travels is called a light year. What distance does the light travel in 1 second? Approximately 3 lakh kilometers, right? So imagine how far this is. And this is just one photo. And contrast this image, the detail of this image, with the first photo that we saw by Voyager 1. It's very blurry, right? And how far science has come in terms of understanding our place in this universe. The next thing I want to bring to your highlight is something called light pollution. And this is something that we struggle with a lot as astronomers. This is a video of how light pollution has increased in India in the last 7-8 years. You can see that there are still dark skies. The green parts are light areas, and if you see, by the time we reach 2023, things have become quite bad. This is the latest image. We don't have dark skies anymore in India, other than some spots in the Western Ghats, some areas in Rajasthan, and the Upper Himalayas. That's it. And as we grow as a civilization, as we grow as a country, we will keep on losing these dark skies. So my request to you all is that whenever you get a chance, just look up. Know that you are part of a tradition that goes back 10,000 of years. Find your local astronomy club, find a dark sky, go out and see and observe the beauty of stars. All right? Thank you, guys. Have a good day.
Thank you very much, Varun, for that wonderful presentation. I have one request. I have two requests, actually. Request you all to please turn off your phones or put it in silent, please. That is one thing. And especially in the back there, if you can maintain a little bit of silence, it'll really help the people who are presenting here. Really appreciate that. So thank you once again, Varun. What you heard was an introduction to astronomy, as we both said, astronomy 101. Now, astronomy itself is divided into multiple fields of study. There is astrophysics, there is cosmology, there is planet science, there is astroseismology, there is astrobiology, you name it. And there is the king of all realms of astronomy called visual astronomy, my personal favorite. Now, Akarsh and Gautham, they are going to talk about visual astronomy, basics of visual astronomy. Uh, I'd like to invite Gautham and Akarsh to help us understand visual astronomy. And let me tell you here, it's hard to find a better bunch than these two guys to talk about visual astronomy, given uh, their knowledge of the field. Now, personally, for their folks, they're trying to get them to get married and settle down, but they've so far they've been very successful at evading it, saying that they're married to astronomy, and instantly Akarsh's mom is right here. So I'm glad I could put you in the spot, guys. So take it away. It's all yours. How you interpret the marriage part is left to you, but
Gautham is the main speaker. By how many minutes? 15 minutes late, right?
we're about, let's say 10 minutes late, 10, 12 minutes.
There's a good amount of our presentation.
Okay, so you can
so thin down on elliptical, types of galaxies, types of nebulae.
so you'll have to probably cut down about 10 minutes or so.
Okay, we'll try. It's hard to do that, but we'll catch up somewhere. Mic could do that.
Is it supposed to be turned on?
mic? Do you have a second one? Yeah. Oh, well,
Yes.
is it live? Oh, yeah.
Is it supposed to be turned on or something?
Yeah, it is turned. And both will be on the live stream? If you want to mic. I mean,
Yeah, you're
I think
live
it's fine if both of us mics are just on.
Both of you are live now.
Yeah, okay, great. It's Akarsh and Gautham, the very first one. Yeah, that. How do we switch slides?
You can use that.
How did he switch slides?
Yeah.
Oh, Varun, how did you switch slides? How switch slides? Next slides? Okay, fine. On the keyboard. Okay. We can just use the keyboard.
Yeah, that's fine.
Okay. These buttons work, is it? Okay, great.
Sorry for this.
Oh no, I mean, the fact that we are successfully streaming this is a.
Red laser is okay, green laser is not okay.
Which of the button? It's on.
Yeah, just try it out.
Okay. Well, welcome everyone, and thanks for joining us on a weekend morning for this workshop. And if you guys are sitting here and it's house full, that means that we have a lot of enthusiasts who are interested in astronomy today, right? Well, thanks to Varun for introducing astronomy in such a beautiful way, and thanks Nandan for um, a great introduction to us. And so today I'm going to be taking you through the basics of visual astronomy, and like
Nandan mentioned, this is one of our favorites, one of the favorites among the amateur astronomers, and there is a reason why it's our favorite, right? So, what is visual astronomy? As the name suggests itself, visual astronomy is nothing but looking at the objects in the sky with our eyes, and as opposed to looking at the objects on a computer screen or in photographs, this is a much more personal experience that we hold. And I want to stress on the fact that um, everything that we see in the sky outside of the Earth is in past, right? Including our very own sun, right? So anything that we see in the telescope, with the telescope or without, we are looking way in the past, right? So here we see a beautiful image of a young kid enjoying probably the view of the moon, uh, just during sunset. So let's see the history of visual astronomy. Initially, in the olden days, visual astronomy was primarily the only way to discover objects and for studying the universe and what we had outside, whatever looked like dots and patches of light in the sky. The only way to study them was through visual observation. And so, in this image on the left, we see one of the great astronomers, William Herschel, and his sister Caroline Herschel. Right, so he's with his um, telescope trying to observe and make notes of it. And what you see on the right side is actually the sketches that he made and made notes of what he saw through his telescope. Right, so today, visual astronomy is not primarily used for studying the universe itself, since we have more advanced technologies and more advanced ways of studying the universe and capturing them with cameras and everything. So today it's mostly done for fun. We do it for hobby, and there's a lot of us enthusiasts who just enjoy the view of these beautiful objects that we see in the sky, right? And so we all know who Galileo is, or at some point in our lives, we would have heard who Galileo is, right? So, and Galileo is considered to be the first person who pointed the telescope at the sky, and he was also the person who discovered the four moons of Jupiter, right? And he used to make sketches and logs of these discoveries that he would make, or the observations that he would make. He would, note the sketches. He would make sketches of the moons, the craters, and all of that he saw. Yeah. And then moving on to Charles Messier. So Charles Messier is one of the most common heard names in astronomy. And if you go to talk to any of the astronomers or amateur astronomers, Messier is something that you come across a lot, right? So who was he, right? Charles Messier was another one of the really important people from history who was essentially a comet hunter. He was just looking for comets in the sky, right? And he saw a lot of fuzzy objects that were in the sky, and he used to use his telescope to see and observe what they were and make notes out of it, right? And he observed that a lot of these objects were not moving, right? And they were just fixed and in one part of the sky and did not move over time as he studied. And he made a note of these fuzzy objects or nebulous objects and created a catalog, which we now call it the Messier catalog, that has about 110 Messier objects, which contains different types of objects, including galaxies, nebulae, and star clusters. And we'll see more about it later, right? Yeah, so moving on to the Herschels, they are another very passionate set of people, actually a family of four. And who we see here is Caroline Herschel. Caroline Herschel, this is William Herschel, and this is John Herschel, right? And so the family were this family was very passionate about astronomy, like a lot of us here, and they made notes, they made observations, and they discovered thousands of objects, including Uranus. Right, so we've been hearing the word nebula all across, right? And what is this nebula that we are talking about? So originally, so when we spoke about all of these historians and the great figures from the past, anything that they saw that was fuzzy was called as a nebula, be it a star cluster, a galaxy, or any other object that was just fuzzy, it was called as a nebula, right? And so now in the present day, we have a more clear idea of what these nebulae are, with more observations and study, right? And what we see here are some of the examples of the objects that we see in the sky, right? So we now know that some of these are just gas, some of these have stars in them that we can see and distinguish, but in the days back, in the olden days, they were all just considered as nebulae. So this is an example of all the cool things that we get to see as visual observers. So we see a few objects from our own solar system and few beyond, right? So we know that when we look up at the sky, even from Bangalore skies, we see a lot of bright lights. And in the night sky, we see a lot of bright stars, and some of them tend to move, some of them are just staying there, but we don't know what they are, right? So what we see here, can anyone tell what this first image is? Okay, anyone else? This first image that we see is an object that we often tend to get confused with with something related to astronomy, but this is actually the headlights of an airplane that's passing by, right? And the second, bright thing, or the star that we see in the night sky is a shooting star. This is more common among us, or we might have heard a lot about it, if not seen, right? So these are essentially just ice crystals, and that just vaporize when they enter the atmosphere, and they create a fireball, or just light up when they due to the friction, and we see a show which looks like a shooting star. So the next kind is, it looks like a star, but when you observe it, it might be moving across the sky, right? But a star can't move across the sky in a fast pace, right? So what are these objects? So one of the examples shown here, can anyone tell what this image is? Right, that's right. So another object that we can see is the man-made satellites that revolve around, right? So these light up, reflecting the sun, and these look like stars in the sky, but they'll be moving. And we also see another kind, just like stars in the sky. And can anyone tell what this could be? right? So this is, yeah, so what we see here is actually a planet. So we can see a lot of planets with naked eyes, including Jupiter, Saturn, and the brightest of all, the Venus, right? So this is probably Venus, what we see here on the image here. And the easiest way to distinguish if it's a star or a planet from a city sky is to see if it's twinkling, and if it's not, it's a planet. So let's talk about the cool things that we see right around us in our own solar system, right? So we saw a lot of cool images. We've seen a lot of cool Hubble images of the objects from deep space and planets and everything. We have some cool phenomena and events that occur in our own solar system that we get to observe, right? So the first here we see are the craters and valleys of the moon. We can see the rings of the Saturn, and quite honestly, that is one of the most beautiful views that you can ever look at. And we can also see the dust bands and the dark spots and the storms on Jupiter, right? And we can also see the polar ice caps of Mars. And did so we see Venus phase here. Can anyone tell me what this means? Does anyone know what a Venus phase is? Right, that's right. That's absolutely right. So all of the inner planets, right, all the planets and the satellite between the Earth and the Sun, they undergo phases just like our moon. And this is one such example that we see here, right? And another cool thing, which you all would, be observing today as well, is our own sun, right? So we see, very cool features in our own sun, including the corona, prominences, and sunspots. And can someone tell me why the image is black here of the sun? Right, that's right. This is a total solar eclipse. And do you think these all of these features are visible during all the solar eclipses? What do you think? So what we see here, the prominences and the corona and all of these are actually something that you can see with the aid of, absolutely nothing sometimes, and with the help of just binoculars during the total solar eclipse, without any special aid, right? So along with these, we also have occasional visitors in our solar system, which we call the comets, right? So these are just lumps of gas and dust and ice crystals that just passes through our solar system and lights up, and we see the light and the tail when it passes close to the sun. So moving on, let's go deeper into the sky and see what we have, right? So we see a lot of these stars, in the sky, the constellations, and some of these are, star clusters, right? So when we go deeper with the help of a telescope, we have the star clusters. And so we have two different types of star clusters. I'm not going to bore you with the details again, since Varun already explained. But to give you an idea, so open star clusters and globular star clusters are, the stars that are born together, right? But they are in different forms. One is in the shape of a cotton ball or sphere, and the other one is just, loosely packed, and they're just freely, shaped. And then there is the second type, the nebulae. So here we see a lot of different colors and um, different forms when we look at the image, right? So all of these show different stages of the life cycle of a star, essentially. So what we see here, the dark nebula and the emission nebula is the birth of a star, right? So the planetary nebula and the supernova remnant are death of a star. And what we see here is just a phenomenon because of the brightness of the star. The gas surrounding the star is just reflecting off the bright light. And then there is a third type, which has various different classes within it. And these are the galaxies. And these are classified primarily based on its size and shape. So when we look at a galaxy through a telescope, right, we see some of them are, they appear like a disk. Some of them appear like a thin line, right? So what are these? So these are essentially galaxies. We're just looking at the galaxies from a different angle. So one is just face on, and the other one is, from a side angle or perpendicular angle that looks thinner. That is the edge on here. So we saw a lot of these images, and we saw all of these objects, different objects, to observe. I mentioned that it's very cool to see a lot of these objects, but how do we keep a track or make a list of what to observe, right? So to help with this, there's something called as the catalogs, right? So what these essentially are just designations and names given to these objects in the sky to help us, just to know what we are looking at and to identify them. Right. Some of the more well-known catalogs are Messier catalog from Charles Messier, and the New General Catalog, or the NGC catalog. So let's talk about the different types of telescopes that we can use to see all of these. So one, the most affordable one, and the more commonly accessible one, the binoculars, which uses primarily lens and prisms, right? The second type is a reflective mirror. And the third type is a catadioptric telescope that uses lens and mirror, right? And the fourth type is a refracting mirror, refractive telescope, which uses just the lenses. Right. So I would like Akarsh to talk about this slide and the next, because uh,
Yeah.
he's the perfect one to do this.
I think my mic is off, so I don't know how to turn it back on. So I'll just borrow your mic. Okay. So um, when we think of telescopes, normally we think of them as things that magnify the image of Saturn or Jupiter and so on, and present. By magnify, we mean zoom in, like make it bigger and show you a big image of the planet. But the real purpose of a telescope, especially when it comes to deep sky objects, those extended objects in nebulae that we've been talking about, is not its magnification. In fact, when you buy a telescope, you are not thinking about magnification, because the magnification of a telescope can be changed by changing what's called the eyepiece. That's the part that you put in the front of the telescope. Okay, right here where you observe. So instead, the important contribution of a telescope is actually to gather the light, the faint light from the distant object, and gather as much light as possible, much more than what our eyes can gather, and concentrate it and focus it down such that it intensifies the image, right? So you can think of so the primary light gathering element of a telescope, like it's, if you're thinking of a reflecting type telescope, that would be its big mirror that is that sees the light. The size of that is what we call the aperture. That is a measure of the light gathering ability of the telescope. Okay, just like a big bucket gathers more rain drops and fills up more water, and a small bucket gathers less, a big telescope is going to gather a lot more light than a small telescope. And the magnification you can always change by changing the eyepieces. So the important thing is you always want to have as big a telescope as is practical to observe the night sky. Okay, and so that leads to something called aperture fever, which is a disease. And the disease is you start with a small telescope like this, and then you go to this next size, and then you go even bigger, and finally you become so big that it's unmanageable. That last telescope is not mine; it's a friend's. Uh, and so the larger size of the mirrors of these telescopes progressively allows you to see fainter objects, but there are a lot of challenges that come with it, which is portability, the stiffness of moving it. You have to design it well, otherwise it will be too stiff, and then the weight. This is my current telescope, which I'll talk about at the end. It weighs about 300 kgs total, no, 150 kgs total. And the cost, they get progressively very expensive, and so it's important to not go down the slippery path for your own sanity. Okay, so back to you. It's on.
Yeah, thanks, Akarsh. Yeah, so he's one of the examples who slipped into that path of aperture fever, and we hope to not follow that, although we are very tempted. So we see a lot of these objects in the sky, and we were introduced to something called as the stellarium. And how do we point at an object? So we know that they are in the sky, but how do we find them, right? So we use three primary methods to find them. One is the manual. So we make use of physical maps or softwares like the Stellarium, and we use um, the identifiable patterns of stars in the sky, and then just hop to the object. And the second type is a device that uses a database and connects to the internet and tries to solve what's the pattern that we see in the sky using a camera, and then nudges us to push our telescope to find the object. And the third type, the go-to, is a kind where it does it all for you. So you punch in the name of the object or the designation, and then well, that's it. It just finds it for you. You don't have to do much work at all. Right. And so we heard a lot about light pollution. So what does this light pollution do, right? So what we see here is an example of a deep sky object. What we see here is the Andromeda Galaxy in the constellation Andromeda. And what you see on the left is in a light polluted sky, right? This is just a depiction of how, light pollution affects, right? So we barely see the object, right? So we actually don't see the object at all. But when you go to a dark sky, this galaxy is actually visible to the naked eye, right? Let alone the stars, the fainter stars, the galaxy itself is visible to the naked eye. So that is the importance of the dark sky, right? Okay, so yeah, let me just quickly wrap this up, considering the time crunch. So this is another example of the difference light pollution makes. So another heads up for all the enthusiasts who want to observe, right? So we have something called as the cone cells in our eyes and something called as the rod cells. So in the dim light, these rod cells are what is active, and during a bright environment, cone cells are also active, and due to that, in dim light, it's hard for a human eye to catch colors. So what we see are gray patches and monochrome while observing. Right, so we see all of these objects, and how do we remember what we look at, right? So one way to do it is through logging and keeping notes. Some of the observers like to write what they observe, describe everything, and then some like to sketch it. So what you see here is actually an example of a sketch that was done at the eyepiece by a visual observer. So this was what was seen at the eyepiece. These are some more examples of sketches. And just to show what sketching process looks like, so this is Akarsh trying to sketch from the eyepiece. So the process of sketching is essentially just candid, making notes and jotting it down, or sketching it from the eyepiece, as opposed to processing it later, or taking reference from an image, right? So that's visual astronomy. And if you have any questions, you can throw them at me, or save it for later.
Thank you, Akarsh. Thank you, Gautham. Wonderful, wonderful presentation. A lot of insight into visual observation there. We now break for tea, coffee, and we reconvene in about 5 or 10 minutes. But before you go ahead, I'd like to tell you something. So as Gautham mentioned, everything that you see naked eye, standing on Earth, everything that you see naked eye is within the Milky Way, except for one object, which is another galaxy, what we call the Andromeda Galaxy, M31 on the Messier catalog. Messier M31 looks like a small cotton ball. You can, even from Bangalore skies, on a clear night, you can see Andromeda Galaxy. From Bangalore skies, seeing it naked eye might be a challenge, but if you head out into dark skies, you will surely see it. Many of us, we have seen Andromeda Galaxy naked eye from dark skies. So this is like Milky Way itself is anywhere between 100 billion, they say, 100 billion stars, 100 billion stars, give or take a few, 100 billion stars. And Andromeda Galaxy is another, let's say, 100 billion stars. And that is just really the tip of the tip of the tip of the iceberg. So think about how big the universe is. Think of the billions of galaxies that we have. Think of billions of stars that we have. And think how big the cosmos is. With that as food for thought, let's go have some coffee and tea and reconvene here in about 10 minutes.
Students and participants who have not signed the signature over there, please, it's there, the help desk, please drop by and put in your registration. Thank you.
Yeah. Folks, a quick announcement. We have the registration list here. There are a lot of people still haven't signed. Can you please raise your hands if you haven't signed? We'll come down to you. We'll get your autograph done. Anybody? There's one person in the back. Catch hold of him, make him sign. Sign on a blank sheet of paper. So everybody here has signed? These signatures are important because that's how you'll get your certificates at the end of the day. Think about it. We're running short of time. Please settle down.
Can you ask him to take a look at Akars's article? Because but you ask him not to take photos.
Yeah. If you look at the sides on either side here, there are a bunch of posters. There is one very interesting article that was published on Sky and Telescope. Sky and Telescope is a leading magazine in the world of amateur astronomy. Akarsh, who just spoke here a couple of minutes ago, Akarsh authored an article there, One Night of Stellar Evolution, a wonderful article. I strongly recommend all of you take a look, spend some time reading it. Take a look, read it, but please do not take pictures and disseminate it. If you take pictures, keep it to yourself. This is IP protected material. If you do take pictures, keep it to yourself. Please do not disseminate. It's a wonderful article. It runs into three, 4 pages, but there are some very interesting topics there. I keep repeating myself. Anybody who hasn't signed the registration form, please do that, because that is how you will get your certificates at the end of the day. We have the registration forms. Oh. Okay, let's all right, let's get started then. Yeah, that was one very good session by Akarsh and Gautham, brilliant as usual. We live in a world far different from the Galileo Galileis or Charles Messier's. This day we have the power of technology. Your smartphone that you carry in your pocket probably has more compute power than high performance computers just a decade ago. We are going to use that fact to our advantage. Ranjit is going to walk you through uh, how the night sky changes as time changes or seasons change. And it is for this reason that we asked you to install this app called Stellarium. If you still haven't done it, now you can do it now. It's a free app available for both iOS and Android. So if you haven't installed Stellarium, let's go ahead and install it. And yeah, let me introduce. Let me ask Ranjit to come over stage and do the demo. Ranjit, it's all yours. Yeah. I had this request to leave lights on so that you can take notes. Is this light scheme okay? Is this good enough to make notes? All right. Thank you.
Yeah. Thank you once again for being here. So this is more a practical session. So we have seen many things about the different objects that you can see right from the planet, the stars, the galaxies. But like you actually have to go out and see. So let's say you are actually one fine evening, there's a slight breeze, you're on your terrace, and you see a bright object, and you've always been curious, what that bright object is. It could be a planet, it could be a star. So we have, as Nandan mentioned, we have quite powerful tools right now to actually explore the night sky, to find what that particular object is, which probably wasn't there, 60, 70 years back. So this is essentially a planetarium software. So there are many planetarium software out there. You have Stellarium, you have Sky Eye, you have Sky Safari. So this is more of a practical demo of how to use the particular app that we are talking about, which is Stellarium, how to use it to actually explore the night sky. So there is no need to be, to think, oh, what's that particular bright object in the sky? I don't know, what could it be? You can always use this particular app to see and explore what that object actually is. And if you're really curious about it, then you can explore more about that particular object. So what I'm going to do right now is I'm going to, so I will just project my screen over here, and I will open Stellarium, and I will go step by step. So this is more of a practical session. So you may have to stand up, you may have to turn around, you may have to see which is your north. That is, you have to orient. So you don't know where your north is, south is, east and west are. So you may have to stand up. It's up to you. You could sit and do it, or there may be a necessity to stand up and actually move around. So it's like an exercise post your coffee break. Okay, so let me just connect. So you can open Stellarium. So I'm just going to project it. So have you opened it? Okay. I hope it comes up. Okay, I seem to be having some trouble. I think it's trying to connect, but it's coming. Huh?
Detecting?
Yeah, I mean, so it's detecting that particular thing.
Two devices connected by any chance?
See, it comes. That is the one. It shows the.
But this is
Yeah, I mean, the conflict is because two devices are
Okay, maybe you can switch that off. I think it's trying, but okay. Let me try now. Yeah. Let me try now. I think it's fine. No, no, it's still. No, just. Yeah, it's trying to, but it says
You're not connected to the same Wi-Fi.
this GI
Yeah.
2G. Then I cast. Get this.
It's not detecting. Can you just
You want me to restart?
no, no, just go on airplane mode and it can try to. Yeah, yeah, it's coming.
Oh, did I switch off? Oh, wait. Okay. I'll do it again. Let's see. Okay, let me try again.
Now you can try.
Yeah. I'll try again. Can you? Is it possible to switch off and switch on the wireless display? Just switch off and switch on. Wait, I can see it. Okay, I'll just cast now. Okay. Please show. Let me just switch off my Wi-Fi. Yeah. Should show that blue screen.
No, I mean the first thing is it should ask to connect.
Oh, is it? Oh,
Yeah, yeah,
I should be seeing something there.
yeah, yeah. There should be a pop-up that should come up.
Mm-hmm. I will.
Stellarium on your phone. We will
Yeah,
step
yeah,
it
yeah,
up
yeah. I
and
think
help
that's.
you to create
Yeah, yeah,
Stellarium on our
yeah, yeah. We'll. Yeah. I think.
we can use this time to explain the activity.
Or I'll just show it on my thing and then People have to follow you. Okay, I think I'll just show it. I'll just show it on. Okay, guys, we have some trouble. So what I will do is I will show it on my mobile. Yeah. So okay. So we seem to be having some trouble connecting to the display. So what I will do is I'll show it on my mobile. I'm sure you won't be able to see my mobile, but we will have people going around trying to help you out. What exactly I'm trying to convey. Okay. So let me start off. Uh, yeah. So yeah. So open your Stellarium. So you should see something like this. The thing is, you will see that the sky is, so this is the landscape, the black thing that you see over here. Let me just increase the brightness. Okay. So you will see a black, you will see a, like, a lot of trees and things like that. That is the landscape. Okay. So, so that's the landscape. And if you just move your phone, you will see that the sky also moves along with it. So are you able to see that? Just move your mobile and see that. So the first thing is, so how does a planetarium software work? So the way it works is, you given the time, the date, the place, you can actually exactly you can know by computations how the night sky looks like, or the sky looks like in general above you, wherever you have. Yeah, sure. So the first thing that you need to make sure is make sure that your latitude and longitude, that is, you are in Bangalore right now. So that is your place on the sphere of the earth. So you need to make sure that, that you are at, that is, you input the right latitude and the longitude. So by default, you will see that the network, if you have the network, it will take the latitude and longitude uh, that automatically it takes from the network. So you don't have to worry about that. So how to make sure that your latitude and longitude is correct is on the top, you will see a bunch of lines. Are you able to see that? Yeah. So if you click on that, so if you click on that, you should see sky cultures, calendar, observing tool, settings. Are you able to see that? Okay, great. So if you click on the settings, you will see location. Are you able to see location? Yeah, click on location. When you,
It's not that audible at the back.
okay, so if you click on location, you will see latitude, longitude, named city, and UTC offset. What do you see? Do you see Bangalore? Okay, great, very great, good. So then what has happened is the network has automatically taken the latitude, longitude based on your, like, you're connected to the the wireless network, the cellular network, and it has taken the your geolocation from the tower. Okay, so that is to make sure, because if you give some other thing, the sky, like, if, for example, if it is Adelaide in Australia, the sky is going to look completely different. Okay, so if you come out of location and click on advanced. So what this advanced thing gives you is, you see two things, limit magnitude and brightness. Okay. Okay, okay, so it's fine, don't worry about that, it's not important. Okay, let's get started. Okay, so just imagine, you see that that particular evening the sky is pretty clear, you see some bright objects in the sky, and you're really interested to know what those particular objects are. So what you do is you take your stellarium, as make sure it is the right, and what you do is, so you see that first thing is you need to know what's your orientation, that is, where is your north, south, west, east, those direction. So can you see, if you keep like this, you will see some, a letter W in red. Can you see that if you keep moving? If you move towards this side, all towards this side, towards this corner. So do you see west? Okay. So that's your west. Okay. So if you move towards that direction over there, that's your north. Okay. And if you move it towards this particular direction, that's east. Okay. And of course, that is south. So is everybody on the same page? Are you able to see these are called the cardinal points. North, south, west, east. These are your cardinal points. So are you able, does anyone have any issue or trouble? Okay, I am assuming everybody is okay. So okay, so this is what you are orienting yourself wherever you are. Let's say you are on your terrace and you are orienting. So okay, that is north, that is south, that is west, that is east. Okay, that is the beginning. Okay, okay, sure. So let's say, so what you see is, and the time, what is that? So you see at the bottom, there is a particular time. I don't know what it shows on. So if you tap on it, you can actually set the time. What is the time that shows in your Stellarium? Sorry, 11. Okay, just bring it back to somewhere like 1930. That is 7:30 in the evening. You can, yeah. So there is a slider at the bottom which you can move. So you just, or you can, what you can do is you can actually tap that particular time, and then you can, so you can actually, if you see, you can actually move the time. Okay, like this. So I've got it to 9:12, around 9:12. Okay, so now if you see there's a bright object, you're on your terrace, and you see there is a bright object in your western horizon. So what you do is you just point towards the west. Okay, so you see, okay, there are two, can you see two objects, two bright objects in your Stellarium? Just click the brighter of them. What is it? Venus. Yeah. So it's like you saw something in the evening and you don't know what it is, and you can use this particular app to point at that bright object and click on it and find out what that particular object is. Okay. So you see Venus is about to set. Okay. So you can actually now below Venus there is something else, right? Spica. That's a star. Okay. So you can use, there are two bright objects in the western horizon, and one is Venus, quite bright, and the other one is Spica. Okay. Now, if you move slowly towards your up, you will see another bright object. Can you see that? That is, you have to move from west towards the top. Yeah, Arcturus. Okay. Can you see that? It's somewhere over here. You have to see my orientation. Okay. So that is the star Arcturus. Okay. Is everybody on the same page? Okay. If anybody has any trouble, there are people to help out. Okay. Oh, great. Okay. Fine. Oh, thanks. Okay, great. So we are right now. So so we are at 9:30. Can you see the time over here? So I've kept to 9:30, around 9:30. Oh, sorry, 7:30. Okay. So there were two. So that is Venus and Spica. So now I'm going to move. You see? Okay. So there's another bright object. So let me do one thing. So I'm just going to simulate a night sky, a light polluted night sky. Okay, so that I don't see the other stars. So there is another bright object, which is a star called Arcturus. Okay. Now, if you move, up, you have to go up. You see another star called Vega? Yeah. Okay, so Vega is pretty much the brightest star other than Sirius in the night sky. So you can't miss it, okay? And then if you move slowly towards your north, okay, you will see another bright object. You can click it. What is it? Deneb. Can you see? Can you see Deneb? Yeah, you. So this is you will need some exercise for this. Okay. So can you see Deneb? Yeah. So if you actually bring, you will see a picture of a swan. Can you see? If you bring your, if you point, you can see. If you're having trouble, just look at this. Okay, what I'm doing. So I'm moving towards Deneb, and you will see that you will see the constellation of Cygnus. Can you see that? Yeah. So it looks like a swan. Can you make out the shape of a swan? And there is also an image which looks like the swan, right? So Deneb, actually, lot of the names of the stars are actually in Arabic. So Deneb means the tail of the hen in Arabic, but in more modern, the name is Cygnus. So Cygnus comes from means the swan in Latin. So it's more of a Greek name, Cygnus. So that is the constellation of Cygnus that you're looking at. Okay. Once again, if you just point over there, so you can make out the shape of Cygnus, right? Yeah. And so now just have a look here. So I'm going to move a little more higher, and almost overhead me, I can see the constellation of, sorry, you can see Altair, right? Okay. So this is, so okay, come back. It's all right. It's okay. You literally have to stand up and do this because astronomy is not a sedentary exercise. So you have to go out, you have to stand up, move around. So it's a good exercise. That's one thing. Okay. So so this is pretty much how an evening sky will look like on a decent, even if the sky is quite clear in a place like Bangalore. I encourage you, go out on your terrace, use this particular app and see a bright object and be curious about it, what that particular object is, point at it, and it will tell you, okay, what star is it, what part of the constellation it is, those kind of information. Okay, so you, and this is what I'm showing you is tonight at around 7:30 in the evening. All right. So now what? So tonight, you know, the moon is going to rise. So what we can do is we can actually find when is the moon going to rise. Okay. So for that, what you can do is you see the search bar. You can type moon. All right. And then click. So are you able to click? So is everybody on the same page? Okay. Okay. So now what you need to do is advance the time. So if you have any trouble, have a look at what I'm doing over here. Okay. So what I have done is I have actually clicked on this particular time, 7:30, and then I have actually this bar, I am just moving it towards the right. All right. So now I have moved the bar sufficiently. Okay. Are we on the same page? No? What is the problem? Okay, you did not catch. Okay, I will tell again. Okay. So the time was somewhere around 7:30, right? So what I'm going to do is, okay, 7:45 is the time. The time is 7:45. So what I'm going to do is, I'm going to actually click on this time, okay? And then, so you get a bar at the bottom, okay? So move the bar towards the right, okay? So I have moved it sufficiently enough. such that the time is around 10 o'clock. Okay. All right. Is anybody having problems? Please do raise hands. Yeah, move the bar to the right such that it is around 10 in the 22.00. You see? Okay, are we everything okay? Okay. I hope everything is okay. All right. So the moon is going to rise in the east. Okay. So what we are going to do is we are just going to move in this particular direction. Okay. And can you see the moon? You have to just look at my orientation. That's too high. You have to see this side. Can you see? Can you see the moon? Yes or no? Okay, great. Fine. So you can find out what time the moon rises. You can do many things like when the moon rises and when the moon sets. Okay. So you can do all these things with this particular app. And then, for example, you can learn about the constellations. Okay, come back. So for example, let's come back over here, keep the time at 10. So you can see there's a constellation. Okay, there is a constellation. Can you see? If you can't see, you can see the screen over here. So that's the constellation of Hercules. And you can see a particular shape of a warrior. Okay, if you point it over there, you can see the shape of a warrior. And so if you see, what is it that you can study about constellation, you can learn about constellations, you can do these kind of things using this particular app. Okay, so you can understand the constellations, and if you see bright objects in the sky, you can use this particular app to learn about the constellations. Now, assume that you go to a dark site, okay, where out of the city, far away from the city, and you might chance to see the Milky Way. Somebody says that, hey, the Milky Way can be seen from this particular place. So how do you find where to look for the Milky Way? Okay, the best thing is just rotate around, okay, west, east, south, okay. Yeah. So if you go, so south, you have to see my orientation. So in this direction around 9 o'clock, change the time to around 8, okay, 8, yeah, around 8:30, okay, around 8:30 in southeast. So you know that at that particular night, if you look at southeast around 8:30, you will see, one of the arms of the Milky Way. And if you are in a dark site, you will actually see it as a patch of cloud. Okay, and you won't be able to say that, if you're looking at it for the first time, you might just think that it is a patch of cloud, but it is not actually a patch of cloud. You are actually looking at the center of the Milky Way. Okay, you see this particular this region, right? This particular region, that is actually, you are actually looking straight into the center of the Milky Way. All right. So next to that, there is another interesting constellation, that is the constellation of Scorpius. Okay, as Varun said in the first session, that there is a constellation called as the constellation of Scorpius. Okay, so that particular constellation is this one. Okay, it does look like a scorpion, right? So you see it has this is the fangs, this is the tail, okay, and this is a bright star, Antares. Okay, so you can actually, if you are really interested to find, if somebody tells you, you go to a dark place and somebody tells you that you will be able to see the Milky Way,
and you don't know where to look for, you can use this particular app, move the time to that particular time, and just look at, usually the Milky Way is in the south east to southwest. So you can just look in that particular direction, south east to southwest, and see where and which is the best time to see the Milky Way. Okay, so you can do many things. I would, this is primarily a very good tool to learn about constellations. So if you're really just starting off with astronomy, the first thing is just, you don't need very fancy equipment like telescopes, binoculars, and things like that. You can just observe with your naked eye itself. You can observe the stars, how the stars move, the constellations. You see a bright star, you want to know in which constellation it is. You can just point over there and see. You can form the shape of a constellation. Okay, and if you have a question. Okay, so so if you want to know which constellation it is in, so you can just use this particular app. You can just point. For example, you see a reddish star in the east, sorry, in the south. Okay, so this is the reddish star, and then you can see that, okay, there is a bright star over here, over there towards the left, and then you will be able to see the other stars which forms the tail of the scorpion, and then the stars which forms the fang of the Scorpius. Okay, the scorpion, the constellation is called as Scorpius. Okay, so this is a very good tool to learn about constellations and things like that. And let's say you wanted to see, for example, somebody said, okay, there is the Orion Nebula. Okay, you wanted to see the constellation of Orion itself. So what you need to do is, you don't know where to find it, just go to search. All right, Orion. Okay, it says Orion Nebula. Let's click it, no problem. And this will tell you where it is. So yeah, so if it is at the bottom, what you have to do is, you need to press on time and then advance the time. So if you do that, what you will see is, you will actually see it rising. Okay, so it will start pointing, go along with the point. Okay, so at around 2 in the morning, okay, around 2 in the morning, the constellation of Orion is over here. Okay, so you can use this tool to learn about constellations. So just to wrap it up, okay, the story is that so in Greek mythology, Orion was supposed to be a very great hunter, and he used to boast that I can kill all the animals. And the gods got so angry that they decided to put the constellation of Scorpius in the night sky. Okay, so it's a great honor if you are actually projected in the night sky as per Greek mythology. Okay, so we want to find, is this actually true? That is, the story goes that, as Varun was mentioning, when Orion will rise only when the Scorpius is not in the sky, the constellation of Scorpius is not in the sky, or the constellation of Scorpius has set. Okay, so is this true? For that, what we need to do is, what we will do is, first we'll try to see where Scorpius is. Okay, it's around, yeah. So at around 7, you can see the time over there. Around 8 o'clock. Yeah. So this is, the Scorpius is still visible in the night sky. Okay. So just scan and see. Can you see Orion? It's still looking for Orion. Okay. Okay. So you are right now in the constellation of Scorpius at 8 in the evening. All right. So what you do is, can you see anywhere the constellation? What you can do is, you can see whether do you see Orion. Okay. Or you can just click over here. Okay, so what does this arrow show? It means this is the black is the horizon. Okay, so that means Orion is still, you won't be able to see Orion in the sky because it is still under the it's below the earth. Okay, as per your field of view. Now what you need to do is, so let's see when does it rise actually. So, and we will see when it rises, and are we actually able to see Scorpius? Okay, or the other way around, what we will do is we will see when Scorpius sets. Okay, so this is the constellation of Scorpius. So what we can do is we can advance time. So Scorpius is going to set now. Okay, Scorpius is no longer visible. All right. So let's see, where is Orion? Orion is just over here. Okay, so you can see the constellation of Orion rises just when the constellation of Scorpius sets. So that's what it means, that, so you can actually, you can see, okay, you just hear some story and you can actually see whether is this true or not. Okay, so you can actually explore, is this mythological story true, that when Scorpius, when the Orion just rises when the constellation of Scorpius sets, which is in fact true, because just when Scorpius has set, Orion has the courage to come to the night sky. Okay, thank you very much. So this is I encourage you to use this app more. Go out. I know probably it might be overwhelming, but just take baby steps. If you see any bright, interesting object in the night sky, point over there. Search what that star is and in which constellation it is. Okay, thank you very much.
Thank you very much, Ranjit. I hope you have now the very basics of Stellarium. So strongly encourage you to just open the app, just play around with it. There are, just like Stellarium, there are multiple apps. There is, I mentioned this earlier, Sky, SKEYE. That's another very good app. We use it a lot. There is Sky Map. There are at least 10 or 15 astronomy apps. Essentially, they do the same thing. And another interesting thing about these astronomy apps is you can say October 5th at 9 p.m. What is the sky going to look like from my terrace? You can advance to that time, to that date and time, uh, point in the direction that you wish to look at, and on that date, in future, on that date and time, you can see what you can experience what the sky looks like. So that's a big advantage. So yeah, I mean, all right. Now, as I was talking about this earlier in the morning, translation activity. This is something that I want to tell you. Since this is a parallel activity, a bunch of people will be going outside trying to view the sun, and come back in and join the constellation activity that will be going ahead here. Once the first batch returns, the second batch will go see the sun, come back, then the third batch, and the fourth batch, and so on. So don't worry, nobody is going to miss out on any of the activities. We'll ensure that everybody takes part in both activities. So that is one thing. Yeah, when you go view the sun, there are a few things that you need to keep in mind. I know you probably would have heard many people say that do not look at the sun through telescope or through a pair of binoculars. That is absolutely right. Always right. Never look at the sun directly through a telescope or through binoculars. It can cause instant blindness. Never do that. But in this case, we will try and do that simply because we have a filter, a solar filter mounted on the telescopes. So which makes it perfectly safe, absolutely safe to look at the sun. So when you look at the sun, pay close attention to a few things. On the sun itself, on the disk of the sun itself, you'll see some black spots. Does anybody know what those things are? Any guesses? Sunspots. So the sun is going through a cycle, a 11-year cycle, and we are close to the solar maximum. So there is a lot of sunspot activity. As a result, there is also other features called the prominences and the flares. So prominences and flares, you generally tend to see them along the edges of the solar disk. So pay close attention, try and see if you can spot any prominences and flares, sunspots too. We can talk about that later. If you have any questions, we can talk about that later. So I'd like to invite Vaishnavi on stage to conduct the constellation activity. She's going to give you some instructions. Once she's done giving instructions, about 20 or so people, we will step out. We will go to the parking lot and try and look at the sun while Vaishnavi is conducting this activity. Then 20 people come back, the next 20 people, so on. So you get the idea, right? So Vaishnavi, onto the stage, please.
No, I will give the instructions later. No, I mean once the people move, so that for the each group I can.
So you take 20 people now.
No, no, I'm giving the brief, right? Just. Which one? Okay, not this one. Sorry. Where did that go? So, hello everyone. Hope you all had a good exercise. So, everyone get ready to go back in time now. So, I'm gonna give you overview on the Big Dipper, that is nature's ancient clock. So, yeah, imagine long ago when there was no watch, or clock, or phone. So, yeah, with phones at the night sky. So, the night sky, the stars were the only ultimate guide to the people, right? Yeah. So, like one of the most important group of stars where human relied was on the Big Dipper. Yeah. So the Big Dipper, also like known as Saptarishi or the Big Bear. So it, uh, yeah, right. So long ago, people observed and realized that the Big Dipper was the movement of Big Dipper around the Polaris, that is the North Star. So this observation gave them an idea that they could understand the time with this movement. It is, of course, not a random movement. This is Earth's rotation. So Earth not only just moves daily, it moves around the sun yearly. So this so it makes the Big Dipper move shift. I mean, change the shift in each month. So to account this, what ancient astronomers thought, I mean, they found a reference date that is on the March 6th, where the reference time or the reference hand is yeah, the local time. So this is how the we see the Big Dipper. Sorry. So yeah, so the Big Dipper, it acts as an hour hand in the big cosmic clock in the night sky. So now, Yeah, so now, yeah, there were many sailors, explorers, or farmers who were dependent on the night sky. So the night sky, the stars were the cosmic clock to them. And some of the ancient, sailors like Phoenicians and all, they were like sailing around to the unknown places without any maps or without any charts or without any GPS. So how did they know the route, or how did they sail without having any charts? Yeah, they were relied on the Big Dipper. So Big Dipper has two stars, that is Meru and Dubhe. So with that, they have a, it directly points to the North Pole, which gives them the direction of north. So these explorers, so they did not just stop on the north. They even tried to calculate the time, and yeah, they calculate, yeah, and also, yeah, position, sorry, yeah, so how long they had been sailing, or how close they were to the morning. So they calculated all this. So, we have, I mean, other than Big Dipper being a practical thing, there were many other mythological stories, as Varun explained in earlier session. So, for example, there was one, community of people of Canada, Mi'kmaq, for example. They saw Big Dipper as a great bear, or, great bear chased by hunters. So each season told a different story, showing how deeply, the people were connected to the night sky or the stars. So now imagine you're standing outside under the starry sky, of course, when there is no light pollution. So you can straight point up to the sky, and you can calculate the dipper time, seeing the Meruk and Dubhe, just like the ancient people did. So while technology changed and we moved forward, only one thing which remained constant is the night sky. So it the first very clock or the movements, it always continues as teach about the time, navigation, and of course the history of civilization. So next time when you look up at the sky, remember you're not just seeing the stars. You're witnessing a piece of ancient history, a clock that has guided human for 1,000 years. So always there, moving in a perfect rhythm with our planet. So let's move into the activity. So we will be handovering you the night sky of March 16, and protractors and rulers. So I will be instructing you to how to become an ancient astronomer. So you can calculate the time using the Big Dipper and the North Pole. So are you all ready for the activity? Okay. So I think now, Nandan, do we? Okay.
So now, hold on, hold on, hold on. We take the 20 people up.
Yeah, we can do that.
Now, let's see. The first two rows, or rather not this row and the one behind. If you can step out, we can go view the sun. Akash, we can give these guys rows. Oh, these guys are stepping out. Yeah. So row one and two, if you can step out, we will try and go see the sun. All you need to do is, can you go? Wow. Yeah. Just push the door. Push. Snehith is outside. Please follow him.
So how many of you have got protractors, rulers, pencil? So can you form a group among yourselves? Yeah, I mean, can you raise your hands? How many of you got the protractors and all? Okay. So I think we have enough people like. So both the skies which you have are generated for 16th March. Gautam, Gautam, it again went, sorry. Maybe I think I clicked something.
Hey, do you know how to project? Projection.
So do you guys see Big Dipper on the paper? Can you spot? Yeah, yeah. No, no, I'm just asking them so that they will try to find until that. Do we have those two pictures in anywhere? Should I upload in the drive now? These I didn't include in my.
Okay, you're on.
Okay, anyways, I will instruct them. It's fine.
And this is the
Yeah, I will.
pointer is okay, laser pointer is here.
Yeah,
See
yeah,
that? There is this button here.
yeah.
Okay.
No, this is done.
All right, settle down, please. Folks, can we settle down, please?
I think they can do it on this page only, since it is a white paper.
No,
They
but how
can
will they
do it.
track the angle change?
But because we have two different sheets, right? How will
So what we'll do is we'll only ask them to just find the time.
Okay. Time between what?
No, what is the time on this?
Time is already
That's
mentioned
what
here.
it's supposed to not be
Okay.
here. We had other pages, but you got this.
So go ahead.
So do you see the two stars on the paper, Mehrukh and Dubey? Can you spot on your papers? Can you spot the Big Dipper on your papers? Yeah? So this is Mehrukh and this is Dubey. So all of you take your pencil and rulers and then draw a straight imaginary line. Then you will find a Polaris, that is North Star. Are you able to spot two stars at the edge of Big Dipper? All of you will see the tail, and to the end you see two stars. So take these two stars and draw a straight imaginary line. Oh yeah. So which one is the first page and second page that give? Yeah, the first page. First page, yeah, first page. No, I didn't see this. Yeah, the first page. So were you able to find out two stars and draw an imaginary line? So that line acts as a R and in the cosmic clock. You see the clock? So the two stars, Meru and Dubhe and the North Star. So this imaginary line acts as a R and. So by joining this, you're going to create an imaginary clock, which is a 24-hour clock, not like our analog clock, which is a 12-hour clock. Yeah, have you guys completed making an imaginary line? So shall we move to the next step? So now you draw a vertical line from North Star to the straight 24-hour. A straight 90-degree line. Upwards towards the sky. Upwards. So now we have made, the first line was from two stars in the Big Dipper to the Polaris. And now draw a straight vertical line from North Star upwards the sky. So here, this hour and clock, this moves only 15 degrees, not like 30 degrees like analog clock. This moves 15 degrees per hour. Yeah. Just see once. Are they able to understand?
The first line they've drawn, Polaris to
Ah.
Dubé and Merak, they've
Okay.
drawn that. Now the second line that you want them to draw,
The
next sheet,
reference. No, no, no. The same
Same
sheet.
sheet.
Yeah.
same sheet,
Yeah, the same sheet. The same sheet. Yeah. In the same sheet, draw another vertical line from the North Pole in the same sheet, not the other sheet.
they've already connected pole star B. They've
See,
already
now
connected.
this line they've connected.
Yes.
So now there is one more line which will
Okay.
come straight 90 degrees.
So two lines sitting on one top of each other.
I don't think it's a 90 degree. It's a little shift.
Okay.
Yeah, so
Okay.
that
so that is
shifting.
something that people haven't got.
Okay.
There is one very important thing here. If you notice, the line from Polaris through Dubé and Merak is not exactly 90 degrees.
Yeah.
Although you can connect the three lines, it is not exactly 90 degrees. So you have to draw a line from Polaris 90 degrees, exactly 90 degrees, going through Dubé.
No, no, no. Now they've connected that line.
Yes.
Now they're going to make a straight line towards the sky.
Okay. So from Polaris, draw a 90-degree line wherever it leads. 90-degree line
Just-
moving up.
Yeah.
What he's saying is that you can join the north, you can join north to Polaris and to draw
Extend it.
Yeah, that's what extended.
to get a vertical.
Vertical.
Yeah. So see, if you have a confusion, you can just read the last point to draw a straight line, vertical line. See, first step was to draw a line from the North Star, that is Dubé and Merak, till the North Star, and the, sorry. Yeah. Second step is to draw an imaginary line straight. Have you guys got it? So is it giving you the straight exact 90 degrees or little shift?
Shift between these two, like the vertical line versus
Yeah, that.
the angle between each, like what?
Yeah, that's the time. So if it gives you the exact, then it's a straight like 24 midnight. So I think it's giving them the straight line only.
List of names.
So can you guys take your protractors and measure the degree? So is there any angle deviation between the first line and the second line? Do you see any deviation? 3 degrees. Okay. So if the R and points to straight up to top of the imaginary clock, then it's a midnight. So can you guys repeat the same on the second sheet? Okay.
Okay. Next set of 20 people can come there to have a visual of the solar activity. Just 20 people, please.
Yeah.
Two rows go up, go to see the list.
Okay. So now this is showing you the exact, like 90 degrees. So it's a midnight. Now repeat the same thing on the second thing. So here, draw again a vertical line upwards. Yeah, 90 degrees. Angle, yes. Angle. Yeah, now you need to calculate using the formula. Okay, that I will maybe explain you now once everyone is done.
How will you take 90 degrees? You don't have any reference line.
No, this is your reference point.
No point is there. 90 can be like this also.
Straight 90 degrees towards the sky.
You should take this as straight.
Yeah, whatever, just one, that's what, it's all imaginary. You're making an imaginary clock, you're imagining the drawing, I mean, the line and everything. So any reference you can draw as a, see, anywhere you take the 90 degree and this will give you the same degrees, right? You make 90 degree anywhere. That is going to give,
This is what you are
People from third and fourth row for the solar activity.
from the North Star, yeah.
Now if the line is slightly like this, it will become 90 something.
But okay, we'll come back and discuss. So,
What's the formula used for time?
yeah, that's dipper time, and
The next set of rows
we
can
take
also go for the
2
solar activity.
hours into number of months. Like March 6th is
6
our
and 7.
reference
Yeah.
date. So after that, it keeps on adding
Can also be
2
there
hours.
for the solar activity.
Each month it shifts for 30 degrees. The position of the star.
It's not exactly 30 degrees. It, like, see, the Big Dipper moves 15 degrees per hour, not the 30 degrees. Where is it 2 hours?
It's 2 times.
It's 2 times. It's not 2 hours. Yeah, 2 hours. Correct. So you can do the same thing in next page. Now you can use the formula. So whatever the angle you find here, that's a dipper time. You can take the angle divided by 15 minus 2 into number of days. So this was taken on March 16th. So it's like 10 days. So 10 days you convert 10 by 30. So that you, once you start calculating, maybe you will get it. So can you use that formula and try it now? Any? So, any confusions? The next page, have you tried to do? Okay, so now you need to find the time using the formula. This. So only this degrees doesn't give you, see, since it is the same vertical line, it's a midnight. But if it is March 6, then the same hand is going to show you the real time. But here, since it is deviating, so you need to use the formula to calculate. So it's dipper time minus 2 into number of months. March 6 is a reference date. So they found, because since the Big Dipper keeps on changing the. Yeah, you need to use the formula dipper time minus 2 into number of months. Dipper time, whatever the angle you've got, that divided by 15, because dipper hand moves 15 degrees per hour. What angle you got? Yeah. No. See this. What is the angle you got here? RI 30. So that 30 divided by 15.
So basic change, but basic minus taking you have to subtract 3 degrees.
No, that one is calculating the difference, the time elapsed. Another one is calculating the time in both the sheets. So now you calculate the time. Are you still confused? We just need to, yeah, that's what we need, the OHP sheet, and we mark it over there and find the time elapsed. Or else you can just see the shift between the time. Once you find the time in both the sheets, you can just see the shift in the time. 30 by 15 is the dipper time. Okay. Yeah, that is the dipper time. So minus 2 into number of months after March 6. So this was taken on March 16th. So March 6 is your reference time, 2024. So this March 6th and to March 16th, it's 10 days. So again, you have to do 10 divided by 30, because a month, right? After a month. Yeah, months, because this is March 16th. So it's not a month, it's only days. So you'll have to get it in the months. Got it, right? 10 divided by 30.
Then do the calculation part.
Okay. So what is the angle you got here? 30, right? So now dipper time. Sorry about my handwriting. So it's 30 divided by 15. 15 because this dipper, this is, see, imagine a clock here. This is an hour hand. So it moves only 15 degrees per hour. So now this is 30 degrees. So we are taking 30 divided by, so it is 2. So 2 hours after the midnight, or yeah, before the midnight, whatever. Then you are calculating the months. So this is taken on March 16. So March 6 is our reference time. So this sheet is on March 16. So it's 10 days difference. So 10 divided by 30. The formula is months into months. So we are only 10 days apart from the March 6. So we're taking month, 1 month, right, to convert into months.
What about 31?
How many are in March? 30 or 31?
Depends on the.
Yes, depends on the month. So this you're calculating, right? So into 2. So this is 2 hours before the midnight. So what would be the time here? This is in between 2 and 3, right? And yeah, one more thing I forgot to instruct. It moves counterclockwise. Okay, so 1, 2, 3. So where it is exactly? Is it between 2 and 3? Are you understanding? 2 and 3, right? Now you can just keep a protractor maybe. Okay, so see. So this is like 24, then 1, 2, every 15, it's like 1, 2, 3, 4. So you will see this is between 2 or 3. So that will be midnight minus 2. What is the time? Around 2 or something, right? 2 hours. So 2 o'clock. 2 o'clock will be your time. Then whatever you get this difference, you subtract this. You'll get the time. Once you do it, you'll understand. You do it on your own. Then I will explain it. You calculate this. I'll just explain it over there.
This is basically a clear plastic sheet, A4 size, transparencies.
And no, we will just ask them to calculate time on each
That
paper.
is, at best, that is what
That's
we can do. From our generation.
Yeah, you just calculate time on each sheet. And one more thing I forgot to mention was this moves in counterclockwise, not clockwise. So you imagine a clock. See, that will be your rotation. So this R and moves in a counterclockwise direction. So in the second sheet, once you draw an imaginary line and a vertical line, you will need to use this formula to calculate the time. So I think in the first sheet, everyone got time as a midnight, 12 o'clock. So in the second sheet, you will see a shift in an angle. Please note down this formula to calculate time in the second sheet. So how to calculate dipper time is you need to calculate whatever the degrees you get in the sheet divided by 50. Since this R and moves only 15 degrees per hour. And this sheet is generated from March 16th. So March 6th will be your reference point. So it is only 10 days after March 6th. So you will need to calculate 2 into number of months since March 6th. Yeah. See, this is like midnight. It's straight to the 12. So that's, you found the time. Yeah, that is okay.
90 degrees.
Yeah, that is 90 degrees. So it's showing you to the midnight. So you found that time. So that's fine.
Okay. Can I make notes here?
Yeah, yeah, sure.
What is the units of the 2 multiplied by month quantity? Like left is the time, right? So, like
Yeah.
2 into, if you have like 2 months, it will be 4, right? 2 into 2 is 4. Is that like 4 hours?
No, 2 hours.
2 into 2 hours. Like 2 into, it's like 2 months. It's been 2 months from March 6th.
No, yeah, months, right.
Okay, then that's hours, like 2 into
Hours,
is
right.
This is not star, right?
Right.
And there's a big difference. Okay.
Hmm.
Now,
So now this is vertical, so it's a straight up showing that your midnight. So in the next, which one?
sorry.
First sheet or second sheet?
No, I was just looking at sheet. The
No,
time
I
is
think there is some degrees in the second sheet.
yeah, 15 degrees.
That is,
1
can
hour.
you show me?
first
No,
sheet
you
is
haven't
11:40.
done this.
Huh?
The second sheet I'm asking them to calculate.
Okay, okay.
First sheet you no need to calculate because since it's a
Yeah.
straight up showing as a midnight.
But still, it like 2 months means, the 10 days means it's like
Yeah,
11:40,
that,
right?
yes.
So therefore 12 a.m. That is the time.
No, but again it's not on the March 6th, it's March 16th. So you'll need to use that formula, right?
Formula what is given there?
Hmm.
2 into.
Correct. Hmm. Yeah, you can mark it on that. So you can,
So we have to calculate for March 16th.
right.
Not March 16th.
March, March 6th is the reference point because, yeah, that's actually, it was not supposed to give that.
Okay.
You forget about that.
Forget about it. Now,
So
today,
once you find out the time, then you can refer that
no.
if
So
you're
now,
doing it.
now, this is the dipper time,
Hmm.
right? So this is this into 2 into number of months.
Yeah. Yes.
So we have to find March 6th, right?
March 6th. So March 16th. This sky is generated on March 16th.
Okay. No, I don't get it. I don't follow. I don't follow. What should we do?
So this sky was generated on March 16th.
Okay.
So,
Then I'll say March.
hmm.
Okay.
So this whatever. I mean the angle is now 90 degrees. That's fine. But you still need to calculate the time for March 16th because March 6th you know that it's a reference point which is showing up towards the sky. But if it is March 16th, then there is a difference, right? Yeah. So that difference you need to find out. How do you find the differences? Using the formula. So dipper time will be your degrees by 15. Why 15 degrees? Because it's not 12. It takes the degrees.
Degrees. Okay.
Degrees.
So that is 90 degrees.
90 by 15.
20 divided by 15.
15. Sorry, not 90. It's actually 0 degrees. I mean, it's like vertical, straight up to the time.
Okay.
Wait. No, you just calculate that 15, 90 divided by 15.
90 divided by 15.
Ah. Just let me. March 16th.
Okay, I got first one March 6th.
March 16th.
Both is March 6th.
Both is March 16th.
Okay. 6.
Okay. Now 6 is the dipper time you got. And then you calculate. Yeah. So 6. Okay. This is it. Yeah, that is like after midnight or before midnight, 6 hours exactly. Now you calculate the months, that is 10 days. 2 into number of months from March 6th. Yeah. Yeah, just sorry.
Number of
See, number of months is
1.
1, but here you don't have a month. It's only 10 days apart from March 6th. So it's 10 days divided by 30. Just you do this, I'll just get back to you.
So people are getting -8, -10. What is the answer they're supposed to get?
This is what they're supposed to get.
Second, in the second sheet. So
This
people are
is-
getting a difference of 3 degrees here.
So 3 degrees, right? Then they have to calculate using that formula.
3 divided by 15 minus
So
2.
3 divided by 15 will be the dipper time. Then minus 2 into number of months.
So what is the number of months? So
Number of months is, see, 10 days is apart. This sky is generated on March 16th.
March 6th.
So 10 days apart from the March 6th.
Okay.
Like 10 days difference only. So we are taking 10 divided by 30.
Okay, people
Got
haven't
it?
understood that. You need to tell them that.
Yeah.
Actually, they got the answer. So I think they're asking right after.
Okay.
Oh, you got it, Stephen? Oh, fantastic.
So you're getting your understanding, right? How like
More sheets.
no, this I'm telling. So that will be 2 into 10 divided by 30. No, months. It's basically month.
Okay. Yeah. You guys got it?
1/8. No, not 1. Just show me the.
Months or in.
Sorry.
The protector told 27 degrees.
Okay.
So 15 degree means 1 hour.
Correct.
27 means 1.8. So 148 हो रहा है.
Huh. So what is that? 1.8 is before the like midnight or after the midnight.
Oh.
So what time is that?
That we
In a
didn't
24
understood.
clock.
I thought that is
Yeah, that I
timing.
think I need to tell them.
Yeah.
Yeah. So that will be your.
12 minus 1 hour 48
So if
minutes.
it is 1 hour after 12 or 1 hour before 12.
So okay. So tell me that I need to if it is left side, I need to add or subtract. Add.
It's like after. So it's like 2 o'clock.
Okay.
If you're getting 1 hour, then it's 1 o'clock. If you're getting 2, then it's 2 o'clock.
Then it's okay, right? 148 will be there.
Yes, it is
Yeah.
48 minutes. Okay. Assuming that it is the first
What the
photo
final answer
was
is
taken
for
at
the
12
first sheet.
p.m. at midnight.
Okay.
Somebody
This
got
is 148 a.m.
2, dipper time 2 minus 2 minus 2 into 1 by 3.
Movement. One finger is 10 degrees. 10, 20, 30 degrees.
You need to answer that question.
Let me.
Final answer.
I will. I think.
You need to announce about lunch.
And it's. I think people are more confused now with.
Folks, lunch is ready. Whoever wants is done with the activity can go step outside, have lunch, or you can always come back and continue with this. This answer.
Sorry. Let me open this. Wait, I think. Can you come here? Then I was telling them March 16th.
So this is March 30th. From March 30th, let's do present.
If they get the concept, that is okay. But if they try to calculate, then it's wrong.
let's go finish lunch, please. Camera charges delay idara. Security is over there. Oh, hi. Nandan. Oh, Raghul Nandan.
I'm from Hyderabad.
Oh, okay.
Came for this Space Expo. Bangalore Space Expo is going on 3 days. So I thought, why not extend my session and attend so that I can unlearn and relearn.
Very nice.
Last time I attended BAS program was 2012 before that. Vaishnavi Reddy was there. Observation. People went to that hill from where I can get.
Oh, okay. I was not. I don't think I was this one.
Nice again connecting people.
Good, great.
And I like to invite you to Hyderabad.
Okay.
I will post you.
Okay. Have you on the Telegram group? Ask Telegram group.
And maybe I will do it. Actually, I don't have that app.
Okay.
And I don't have space in it.
Okay. So all you need to do is go to bas.org.in, our website, and from there you can easily get our.
And one Dr. Suresh Mohan, he's still there.
He's active. He's active. He is in. He lives in Chennai. He's not in Bangalore. He's active.
Last contact.
Yeah, go ahead.
This workshop is connecting me to you.
Oh, great.
Hey, have a good one.
Good. What's my phone? 98802. No, it's at 91082 04 546. Call me once.
There's no way I can forget your name.
Okay.
The name itself is Nandan or is
Nandan Narasimha.
Nandan Narasimha. What do you do?
I work for, I consult for automotive industry. Yes. 11113.
Have you been to Hyderabad?
My trip to Hyderabad was for once it was for a conference, and it was in the morning. We came back in the afternoon, and then before that we visited Salas.
I am Raghul Manogaran. I do this instead.
Oh. Right.
So that
You can put a face to
straight away it will come to you. You
Okay.
will not have any who is this will get it.
Correct.
That will So I've seen see I need one caliber medal is not one Madhusudan there was
yes.
is he there?
I think hey, Jain Madhusudan sir is still around, right? He's still around.
Oh, that's good. Telugu also. Okay, I want to go with it. I think they close by 6 or something.
No, they're closed only on Mondays.
Working hours.
Yeah, 5:30.
Then I have to leave from this. How far is
JNP is not very far from there. It's, I mean, Bangalore's traffic is a problem. So, half an hour? JNP, half an hour? Half an hour.
So then, so all these things anyhow been online.
Yeah.
Now it's going on, right? Then I can restart the thought, but I'm really feeling very happy. Seeing all these things, like so much of gap, almost anyway. Last activity was about asteroids.
Oh, asteroids.
What they have done is that after teaching also and for asteroids, the asteroids garden in that planetarium. So you are supposed to do whoever conceive that piece is your picture. So you are supposed to put three pieces, only three pieces. So I got that.
Oh, okay.
So that is the fond memories I have. One observation.
These are actual asteroid pieces?
Yes. That was the collection of that gentleman who, but I don't know whether it was distributed to project. But somebody was, he taught how to.
That is very interesting. Not a lot of people have actual asteroid pieces.
You just find out who did that. That was absolutely 2012 or 13. Sure. So that it was some Government of India program. So the joint program with the planetarium, Government of India, DSK, like that. So I came as a participant. Really nice. Going back into the time. I think mentioned all these people were just young. They're just joining at that time.
No, that is Gautham. Akarsh is not here. Akarsh is probably outside. They are trying to do the live solar view. So if you want to go take a look, we have two scopes there.
Maybe you can split it with solar printer. I learned something and
Okay.
so you are holding any technician in this.
You're all volunteers. Trustee is Keerthi Kiran. You remember getting to that name?
I only remember the observers and I knew that some IA people, retired or somebody was there. We don't go into such details.
I just checked your WhatsApp messages. You said you will be sending good software. Not there. I think you might have sent it to somebody else. Sure.
You can use the Apple iPhone to make. You have the iPhone to make, sir. Yeah, iPhone it is there. It's there on the facility. Do you want to take this like a tape? No.
You want the battery? No, I gave you the charger. I put one battery for charging. If you have another, I'll have a battery also. Oh, you want the charger? My charger is not working. There's no laptop here. So you have a mobile charger? Put it to the mobile. No, turn on one of the legs. No, it is too dark.
No, just 2 minutes.
Okay.
Do a Rachi test now. Whether it is, I couldn't adjust to the person. Otherwise, I will just.
Or if you need my battery, no, it's okay. Is the charge battery? Yes, you are. You have to do the writing date.
Nandan, I'm done with that time.
Oh, you're done with lunch? Where had lunch? What else? Okay, once you're done, let me know.
Yeah. We need to.
And you said it's India book or something. Sudhakar. They want to go. What is out there? Pramod and Ranjit.
Yes.
I'll turn on the light. You can charge it here. But Vinay will start first.
బ్రాడ్బ్యాండ్ మంచిగా ఉందా స్పీడ్ ఫాస్ట్ ఉందా ఇంట్లో బ్రాడ్బ్యాండ్ వైఫై బాగుందా देखिए मैं टीवी चैनल को इंटरव्यू देना है 7 o'clock जूम में
Shashi. Check with Shashi. He bought all the tools. I'm not sure if he has a screwdriver.
लाइट आता है ना लाइटिंग कैसा है लाइट हाँ लाइट है क्या ट्यूबलाइट वो सब है हाँ हाँ रे ट्यूबलाइट है क्या लाइटिंग कैसा है लाइटिंग
God, where are those scripts?
LED white
built-in scripts.
For stacking, go to Siril.
Yeah, I'm in Siril.
I mean, go to that.
No, we need one without darks.
Okay, one without darks.
It's there online.
Or you check in this. You use this, check this, as a copy.
శ్రీనివాస్ గారు సో అది ఎన్ని గంటలకండి 7
presentation demo.
Also,
Okay. Thank you. Thank you. So the machining, I mean the grinding will happen maximum on the center of the glass. Okay, why? Because the edge of this tool glass will be grinding at the center of the glass. It will be doing like this. After completing the coarse grinding, that means it starts from 60 grade, 80, 120, 220, 320. I will show you in the afterwards slides in the PPT. Then we will go for a fine grinding, like abrasive used is aluminum oxide. Then after that we will be changing the mode of strike. We used to strike like this, right? So now we will be striking like this. This is a W strike, we say. Okay, this is one time at 120 degree, like this. Again 120 degree, and after each 360 degree of this glass, we will be turning the tool glass 45 degree. So this is the basic process conducted in the mirror grinding. In between, there are some other things like checking the focal length of the glass. We will be just keep this glass like this and keep a steel rule over that. You will find a small bend. It is very minute. It is very less than 1 mm. Okay, so that is the curvature we are looking for, and gradually we will be reducing the grid size to get that finishing. Okay, we can check the focal length practically by spraying the water on this glass and just showing the sunlight. Okay, we will get the image of that sun, and that is the focal length of the glass we are looking for. Okay, glass grinding I am done. If you have any doubt, we will connect afterwards. So after this grinding, we will be going for a polishing. Okay, polishing and all. We will be using some chemicals like cerium oxide, and here you can see one tool. This is a pitch tool. This tool we need to make our own, like some material like coal tar or rosin. I used to rosin for this. So after that, just melt it and pour it on a round platform, and just keep it. We need to keep some wall for this. And after the casting, just keep some nets like this over this, and keep this directly into some hot water. Once it is set, then inwardly keep this mirror over this, so that it will get the exact curvature of the mirror on this platform. Okay, this can be used for the polishing purpose using the cerium oxide chemical. You can see the color, it's a pink color, and be careful, these are some toxic materials, don't inhale. And mirror grinding and polishing is done. After that, we will going for the quality checking of the mirror. So what I did, so there is a small platform, you can see. So this is a kind of glass. Before mirror making, it will be just like a glass. We can mount it like in this platform. Okay. No, Ranji, I'm not showing. Not showing. I will just see in the presentation. Okay, we will be keeping this mirror in this platform, so we can make it using plywoods and all. So the purpose is like here I just made a small tool, so that you can see one small platform, here one battery holder. Okay, here one black color screen. So you can see this screen is made up of did my voice got missed in between? No, okay. This yeah, actually that plastic sheet is nothing but fringes. It having a fringes like 100 lines per inch. So this will create the light interference reflection, so that interference can be used to check the quality of the mirror, how it is, whether parabolic or spherical. If you are going to make that mirror, then just learn about the spherical and parabolic. Just now I'm going to the basic things. After the quality testing of this mirror, if it is not attaining that exact thing, again we need to go for polishing using this cerium oxide. After that, the mirror is ready. We will be giving for coating. Coating means we need to get some mirror kind of thing over that glass, right? So there is some process like PVD or physical vapor deposition. They will keep that glass inside the vacuum. They will vaporize the aluminum. After that vapor, it will stick into that glass. That is the process. You don't need to worry about that. They will do it and give you. Okay. So the mirror grinding is I have finished. So other ingenious item is in the telescope sides and all, we can see some spotting scope. So that also we can make at home. See, this is a small spotting scope I have made. I have made using PVC pipe and an old lens. You can see And the eyepiece, you can see this is made up of a liquor bottle lid. Don't laugh, please. You can see the whiskey bottle lid valve. Okay. So while looking through this, you can see one plus mark inside. Is it visible? One plus mark. That is a small hair I have kept to get the center of that. So you can keep this in the side of a big telescope, and we can spot it to the star or whatever celestial objects, space objects, to focus on it. Okay. So this is some small instrument I made. It like you can connect using one battery, and you can see the light. Okay. You can see the light, right? Actually, this light will be reflecting, and you can see the hole at the center. Sorry, hole. You can see the hole at the center. Through that hole, you can see the interference patterns. Okay. Next, we will go to the presentation. You are okay to go? Shall I? Okay. After this session, you can ask me any questions if you may. You can connect to PPT. So it's something like a little confidence is more than sufficient to make a telescope at your home, okay? Because I don't have that confidence. And this is cost cutting too. Making a telescope at home is cost cutting. Sometimes 1/3 of the cost you might get saved, sometimes 1/4. So if the actual price of the telescope is 30,000, I made this 6-inch telescope. The maximum expense is up to 12,000, including the eyepiece. Okay. PPT. Huh?
How much will an actual 6-inch cost?
It's something like 20 or 30. That laser point. You have any doubt in between? What I did, how I did, why I did, when I did, where I did? You can connect me anytime, because this is a something ingenious item you can make at home. You will get any tutorial from YouTube also, but I'm just experienced in this. So what and all error is happening, that I am aware. So you can mitigate that error also. After looking at this video what I posted in YouTube, one of my friends saw, and he made an 8-inch reflector telescope, and it worked well. One thing is that I haven't seen him directly. He's just a social media friend, and he also haven't seen any telescope. Even I haven't seen any telescope before. I just had a small refractive telescope before. With the pen. Sorry, I'm just running because of the time constraint. Don't mind. Noted. Actually, a small story behind this telescope. Actually, I built it just for my daughter. So when my wife was pregnant, That time I started in the second month. Then I finished and I gifted this telescope. Any comments? You can raise your hand and give. Oh.
How many days will it take to complete a telescope from starting to end?
Actually, grinding a mirror will take 40 to 60 hours. So I started in one Saturday morning, and the entire Saturday I just continued grinding the course. Friday I was on bed just because of curiosity. Actually. Then I just
spread that over a period of week or something.
yeah, weeks, month, I could say month. Even I failed in grinding in the first time. I mean the polishing in the first time. So wasted money for doing sputtering without undergoing the proper test using the raunchy. I said you how to do that raunchy test in the pattern. The interference test I will show you in the presentation. So I will show you how I failed. How for a Cassegrain telescope, so that after grinding I will be doing drilling in the center, so I can show you how the Cassegrain telescope looks. So drilling and all, it's a risky process. We need to get the exact center of that glass, and we need a diamond tools for drilling. You need to get a good experience with the drilling machines. Even I don't have any bench drill, I use my hand drill only. So even I don't have any bench drill, I use my hand drill only. So I'm planning for a Cassegrain telescope. This mirror will end up with a Cassegrain. It's getting connected. You can ask any question. It's getting connected. You can ask any questions in between now. No problem. If it is funny, also accepted. Thank you, gentlemen. So you can see three kinds of telescopes. Can you name it in a short time? What is that? Laser. Okay. This one, which model? Any idea? I don't need any scientific name or something. So how it is working? Like mirror or lens? Okay. Yeah, this will work in the help of a frontal lens is there and one eyepiece is there, like that. So this is the Cassegrain telescope I said. So we may need to here in this location that mirror will be there. We need to drill a hole through this. Okay. So you understood for which telescope I explained this mirror making? Last one I am planning to make a mirror for this, but I explained for this thing only. Okay, this is a Newtonian telescope. So here you can see this is the main aperture lens. The light will come from the infinity and hit over here. It will reflect, and here one secondary mirror is there that is kept in the 45 degree, and that is reflected to the eyepiece focal point. Okay, So we will be arranging the focuser and eyepiece setup here. So there will be doing some small calculation to find the length of the pipe and the diameter and all. Next, please. Okay, here you can see this is while I was doing the 6-inch mirror. In between of grinding, I just took this picture, and here you can see I said you abrasives like a silicon carbide and aluminum oxide, cerium oxides and all. So from 80 grid to 320 grid is silicon carbide or carbonandum, and aluminum oxide starts with the 400 to 1000, and actually we need 1200 also for a better quality. Okay. Yeah. So this is the process I explained how to stroke that mirror glass over that tool glass. Okay. So we will be moving almost 120, not exact 120, almost 120 degree for 3 times for a complete round of this mirror, and after that we need to shift that, rotate this tool for 45 degree in the reverse direction, and once we will be continuing the same strike using this mirror glass. So one cycle is one full rotation of this tool glass. Okay, after that we will be conducting some testing like what is the depth happened and how more cycles we need to do. Okay, so this is the long stroke, and after that we will be doing some short stroke, like a W stroke we could say. So that will be stroking like this much only, not much. And after that we will be testing that glass contact, whether this glass is 100% contact with the tool. We will be drawing some line, check the lines. Here you can see some checked lines. Is it like this? And after that, just with water, without abrasive while stroking like this, we will get to know whether 100% of the surface of the tool is touching the mirror. Okay. Yeah. So you can see while completing the grinding, in this portion the grinding will be done less, but in the center the grinding will be more. So that's why we are getting this curvature. Okay. This is concave or convex lens? Concave. Okay. Correct. So you can see the depth like this. So while doing the coarse grinding, the pattern, the surface pattern of this glass will be like this. Then that is very coarse grinding, like 80 grid, 60 grid, 120 grid and all. After that we are going for the coarse grind, normal coarse grinding, like after 120, 220 and continues, we will get this pattern. The surface texture will be almost like this. After that, while doing fine grinding using this aluminum oxide and all, we will get a pattern like this. While we are going for the grind size like 900 or 1000 or 1200 and all, we will get a fine grinding like this. After this, we will be checking the focal length, finalizing that, and we will be going for the polishing. I said we will be using that pitch tool for doing the polishing. We will be after polishing, we will lose all these unwanted features and all, and the scratches, whatever. Then we will go for the coating. Once we are completed this Ranjit test and it is fine to go. Then after coating, we will get that reflection over here. Here you can see how at my home, how I check the focal length of this glass. I just kept the glass over here, just sprayed water. Okay, just normal water I sprayed and kept over the sunlight. You can see the reflection of the sun. Is it visible? Yes. Okay, so that's how I just set the focal length of this mirror. Okay. Okay, this thing I have shown you how the pitch tool I have made using rosin wax and abrasives, the polished material using cerium oxide and all, and the patterns will be like this. Why these lines are required means while keeping that 100% contact, there will be a chance of air bubbles and all that will lose that contact between tool and the glass, so that will leak in this area. So this will give a 100% contact of the face to face. Okay, this is the Ranjit test. I said I have shown you one device what I made works in the battery. Do you remember? Do you want to show me again? Yeah, this is the instrument. Okay. So, oh my God. Here the light. Come on, come on, come on, come on. Okay. The light from the source is going to the mirror, and we will be keeping that mirror in a 2f distance, because we have a finite value of focal length, and we are not taking that light from the infinity, so we keep in 2f. So we will be keeping this lens and the tool in the 2f distance, and this is the source light. From here it will go to the mirror and reflect, and the reflection we need to take from this hole. So while watching through this hole, we will see a pattern like this. This is the Ranji pattern. Because my mobile was not holding properly, it got some fluffy pattern, but it was very nice to see. Okay. Okay, so this is the final mirror. I got it. You can see a small scratches over that. Even if I continue polishing further, I could have avoided these kind of scratches. But I said you, once I failed grinding the mirror. So this is the thing. You could able to see here the coating is done properly, but here it didn't happen properly. You understood? Is it visible for you? Oh, here you can see the pattern. It's not reflecting properly because it have pits. So these kind of pits we can check using lasers and all. Okay, while showing the laser, it will reflect at the location of scratches or pits. Okay, this is I have made my telescope using scraps, absolutely scraps only. So I used bicycle rims and all. So this is a rim you can see. Okay, this is a children's bicycle rim, and here, excuse me, for collimation purpose, I mean the alignment of this mirror. So you can see 3 screws are there. So we will be keeping that mirror over this platform like this. So actually this is not the mirror. The mirror will be bit thicker than this. You know what is the item I used to make this table? Any idea? Any idea? Any idea? Item or material or whatever? Huh? So no. Actually, it is a PVC pipe, normal PVC pipe. So I cut it, and laterally I cut it, and using our iron box in our home, I just pressed it. So I just flattened it and drawn one circle with the 4 clamps and cut it using blade. So that's how I saved my money. And here you can see some springs in the bottom. So that spring will give a locking mechanism for this table. Here you can see. Got it? Any doubt? Shall I proceed? Okay. Okay, so this is the head of the telescope where I kept the eyepiece focuser. So you can see these are all the cycle rims. See, cycle rims only. So here also some PVC pipe. This is also cut from PVC pipe only. Even you can also make. I just used to hold that focuser. So in this focuser only we will keep that eyepiece. And just to center this piece, this is, have you ever seen this kind of component? What is this? Any musicians here? Any guitarist here? Yeah, it's actually a guitar tightening. Yeah, using that there is a steel wire here so that I can tune it to the center of the telescope. And one more thing, you can see a center piece here. I don't know whether you people might have seen this. Actually, this is taken from the small spindle of a mixie. Actually, it's a fiber. I just broke it, and from inside we can take that brass outside. Actually, this brass is just looks like a small disc with so many holes, and in the center with a big hole. Okay, so these are all material available at our home or scrap shop. Any doubt? Oh, sender, I forgot. Yeah, here this is the secondary mirror. This I bought. I'm not that expert to make this mirror, so I just bought it. And here you can see one small aluminum pipe. This is a small pipe. I just cut it for a just to put that screw. Here I kept one small nut and sealed with the M seal. And this is kept in the 45 degree. We need to cut this pipe in a 45-degree angle. Okay. This is the final output of my telescope. This is how it looks. After this is some modifications I have made, like here you can see some wooden thing and all. So I just changed it to bicycle hub. So that is giving much stability. So here you can see the eyepiece is mounted, and this secondary mirror you can see through the eyepiece, and here the main mirror. Here you can see the small round. This small round is nothing a bindi only, so that we can get the exact center of that mirror just for doing alignment purpose. And this is a small stool, inverted small stool. Here I just drilled it and mounted two pipes, and over that pipe only this telescope is standing. Okay. Okay. Yeah, this is the end of the slide, bro. One video is. So assembly of this telescope, I just took a time lapse video. Just is for 5 minutes. Within 5 minutes, we can complete. It's in the same folder. Yeah, sure. DIY stuff. So now you can see how the structure is assembled. Actually, the uh, truss kind of thing. How I thought of this thing means I would like to travel with my telescope. If I have used any PVC pipes and all for making this structure, then it's quite difficult to dismantle and carry. Now I can dismantle it and carry to any part. So for star parties and all, it's very easy for me to transport, packing and transport. You can play it. Yeah. So here you can see the head, how it is dismantled. Again, it can be dismantled, but some structural issues I kept as it is. So I'm just taking the truss material. So this length of the truss and all can be calculated analytically or practically. I did practically only. I just kept this body in one location and this body in another location, and just to check the focal length of that mirror. So from that focal length, here I will reduce the height, and there will be an effort 90-degree turning. So this distance also I will reduce, so that I will get that pipe length. So with that pipe length, from this whole location to this whole location, I will just check the dimension. So I will mark in the floor just using normal markers. I will keep this body, two bodies like this, two wheels on the floor. Then I will just check, keep this stress element. Then only I just marked. I haven't used any calculation for this. In future only I'm going to do some calculations. Okay. So upper part of the assembly is done partially. So here I am assembling the bottom part. So along with this, I have prepared some collimation tool that is made up of PVC only. We can do collimation using this pipe. It is having a small PVC element with a small hole inside that. That is made up of what I can say, Pepsi tin. Just punch it using our paper punching machine. We can get a small hole perfectly. Just need to keep inside. I haven't bought it. Otherwise, I would have showed you. And actually in this structure I just found a small problem, like this it will twist in its axis, and it will also twist in its axis. So I just constrained using one cross element. You can see one cross element like this. So it will constrain the x and y rotation of the bottom part and top part. Okay. So now we are setting this. You can see the cycle hub, bicycle hub. Have you seen this bicycle hub? Yeah. So on the both side I just kept this. So it is having a good bearing inside that. So that's, it won't stuck anywhere. Since collimation need to be done, I'm not including the collimation thing inside this video because it will take time. So just not to get disturbance, I just kept this spring so that three nuts won't touch the floor. You understood, right? So here you can see a small cable. This is a new mechanism I made it. This is having a cycle cable. So here a small hole with a Allen key. So this cable I can just put inside this and just lock it, so that I can set the telescope to any location and lock it manually. Here you can see one small black color unit here. That is nothing. In electrical laboratories and all, we can see the aid to lock the wires, red color and black color. That is also from the scrap. I haven't spent much money on this. Okay, so while handling these mirrors and all, we need to use proper gloves and all, because fingerprint also should not be touched in the mirror. It will give that impression over that. I'm just assembling the secondary mirror. Actually, this is some jugaad kind of thing. I don't have any proper 3-point collimation thing. So just using strings and all, I'm just adjusting the location. Okay, so here I'm using the collimation aid. So after that, for better collimation, I will keep a laser over here. It will hit and it will come like this, so that we will come to know it is in the exact axis. I'm just placing the mirror over that table. Is it visible for you? Is it hiding? So after putting that mirror, keeping that mirror over this clamp, I'm just wrapping with a Velcro, so that by mistake also that it won't get removed from that clamp. So this is a laser I use. So you can see it is hitting and it is going like this. So I can use this for doing alignment or collimation. So collimation will take a long time. It's not a easy process. So that's all the video. So you have any questions, you can ask me. Thank you. Yeah, I can share, but it's not uploaded here.
Some of these pictures we'll share it on Telegram group. So the Telegram group that you guys join after this picture, you can share some of the pictures.
Even you can also try, if you are touching this kind of ideas, then you might be a better person to find the materials from the scraps. Any questions? What and all I have seen using this telescope? Yeah. Glass. Glass is that you can find it in a normal glass shop. Actually, glass is not a scrap. Because it should have some good quality without scratches and all. So scratches and all means that if there is a thermal difference is happening with a high temperature to low temperature, there is a chance of breaking that glass. Okay.
Any more questions? You can always post it in the Telegram group as well. We'll be happy to answer.
I'm just thinking to do that motorized setup, but next step it is. I have till now I have seen almost all the planets, basic planets, and Andromeda Galaxy and some nebulas, Gauss Nebula, Orion Nebula, like that and all. Yeah.
So if you want to see through his telescope and if you want to attend one of our staff parties, he gets his telescope. You can always do it.
And last but not least, I'm just telling, if you want to continue to see the stars, keep your eyes safe. Don't expose your eyes to very high intensity light. Donate your eyes so that in your future, after your future also, your eyes will be happy and lucky to see the stars of space. Okay, thank you.
Thank you, Vinay, for this informative talk. Our next speaker is Raghul. So he comes from a background of research and development, currently working in Mercedes-Benz as a lead R&D. So if you guys have heard of automated cars which drive on their own level 1, level 2, currently he's working on level 3 now. He's also been fascinated with astronomy since his childhood. He has been associated with BAS for 2 years now.
Of late, he's also looked in his wife Sonia into astronomy that he bought a new telescope for her. So I request Rahul to start off with the astrophotography session.
So that's the teaser of what we'll show, but nevertheless. Okay, we come to one of the very interesting sessions, more towards visual. You get to see a lot of things. So far, whatever we have been talking about, be it visual astronomy and all those, you have to be there in the place to experience it. Of course, to make astrophotography or to do that also you have to be there, but at least I can show whatever we have taken at different places and connect to some stories. So how many of you are interested in pursuing something like astrophotography? Okay, seems quite a bunch of hands. I think after we see this and I ask, maybe the number of hands raising will increase like so. Okay, so this will be our agenda. So I will introduce you to astrophotography and what are the types and how do we do the imaging and what really we do at the spot, and also show you some beautiful images taken by the BAS members. And Subhendu will introduce you to how to make star trails. He will do a live demo of with the images that he has or the raw images that he has. He will show you live how to make star trails, and we will show you Milky Way time lapses. But yeah, Mahadev is not here today, so maybe Vinay will take it, or yeah. Oh, sorry, Snehith will take it. Sorry, I just saw Vinay and told Vinay. Yes, and basic image processing. Again, Snehith will also show you after we had taken the images, how do we do the image processing to really come to a level where it's beautiful to see. We'll also show a small live demo in Snehith. And after that, of course, the Q&A, we are here to take any questions. Okay, so it's 12. So what is astrophotography? I used to keep it very simple. It's an art of capturing the celestial bodies using various techniques of various equipments that's really needed. An amateur setup, like when you say amateur photography, it could vary, or the range of the equipments that you have to use could vary just between a small DSLR, a tripod setup, like the ones we use in our conventional astrophotography, to a very, you can set up an image, complete photography setup inside of a dome in a place like Chile and then operate remotely from India. People are also doing it at the amateur photography level. And there are companies that have such setups. You can rent it, you can image it remotely, take those raw images, and then do the processing at your home. This is also possible. So what are the basically major components, not just of astrophotography workflow, in any photography workflow? We take images, and before we upload into Instagram, we do some filtering or some image processing, right? And then we upload. So that's the same here also. So we do an image acquisition, and also we have to do some photo post-processing for that. We'll look into it in detail. This, what I'm now we are trying to see is the types of astrophotography. Okay, so this is a very broad classification so that we understand or just map in our mind that, okay, we can just classify almost all types of astrophotography into these four main categories. So first is landscape AP, meaning at the landscape level, we'll have a foreground and a background, and then we'll have the Milky Way. It's a wide field of view photography, so that's the landscape. Examples are Milky Way, time lapses, and then some panoramas. Next is the planetary and moon photography. Of course, these are also celestial bodies like the other objects in the sky, but we keep it special because the techniques that we use for planetary and moon is different from the other types of astrophotography. Basically, planetary meaning all planets, moons meaning our moon and the other moons, satellites, and of course comets. Occasionally, they visit us, and that time every astrophotographer jumps into the eye to does the imaging. DSO imaging. This is one of the probably the complex of imaging that's there out of these four topics. So DSO imaging requires a lot of patience, skill, equipment, and on all of the above, luck. Meaning the cloud, it has to be a clear sky, it has to be a dark sky. Yeah, right point, and also money for buying those equipments and stuff. Okay, and of course, special events. What do you mean by special events? So eclipses don't happen every day, and conjunctions, meaning two celestial bodies being in the same field of view. So if I look into a eyepiece of an object and I see, okay, I can see two planets together in the same time. Those are termed as conjunctions. So these are all special events. They don't happen every day. They're not there normally. We come to know that such events are happening. We prepare ourselves and be ready to capture witness. So these are termed as special events. Without further ado, I will try to show you some images that we have taken from the BAS. But before that, so when I talk about landscape, if you see, this is a very typical simple setup that's needed for the landscape astrophotography. So you need a tripod, a good DSLR with a wide field lens, something like 18 to 50 mm, and of course an intervalometer. Anybody knows intervalometer here? Guys are here, have heard of them? So see, an intervalometer can automate the images that you're taking. For example, you will have to set up exposure, aperture, and the ISO, the triangle of the imaging process, right? You can set it up, and then you can ask the camera to take it, say, for example, 100 times. Iterate it for 100 times, take it for 100 images. So all these settings can be done using an intervalometer that's connected to the photography setup. I will tell you why we'll have to take so many images and what we'll have to do. This we will discuss as we see in the next coming slides. Okay, so this was taken by our past member Mahadevan. What do we see here? What is this? Summer arm or the winter arm? Summer? Ponder about it, we'll come back to it. Okay, so this was taken with a DSLR and with a lens that was 18 to 35 mm variable lens at f-stop at 1.8. So this is a very typical this kind of a setup that was used, very simple setup for this. But what's the additional thing that we have done here to take this? We have been to a very dark place. Like Nandan just mentioned in his talk that we have access to certain dark places in South India. So this was taken from Coorg, where we used to have our star parties. So yes. Okay, what do we see here? Any guess? Okay, now let's split this into two. This is the foreground, right? Whatever we have that's on the earth, this we are clear. And the above is the sky part, yes. So we have some setup here. What is this? Has anyone seen this? Yeah, that's there. Okay, the light part is of course zodiacal light. So there's a a structure here, a building structure. It's the Mace Observatory. Is it exactly Hanley or what? It's at Hanley only, right? It's not Mace. Hagar, yeah, it's Hagar. Sorry, this is the Hagar at Hanley. Okay, this is another Milky Way image that was also taken by Mahadevan in Coorg. And Mahadevan is a specialist. He always takes Milky Way images. That's why you see most of our Milky Way images are sourced from Mahadevan's repository. Yeah, different Milky Way images. Okay, here comes another image. So this is also a wide field image. This was taken by Subhendu. We'll also come to stage later and explain you about how to make star trails. So this also was taken by a typical setup, but a little complex setup than what we saw before. So you will see here there is a yes, this is this setup whatever we are seeing here. Okay, this is the combination of exactly the one which we are seeing. Yeah, this is the setup. So what we have here is the camera, the lens, and of course a star tracker. This will help us to track
and counteract to the Earth's rotation, and to the camera it will be like the image, the light it's getting is from a still or a stationary object. So this helps us to make the long exposures. I'll tell you why we will need it. So let's probably delve into it a little once we look into the other setups. So this is now with an additional tracker that will help us to counteract the Earth's rotation. And what do we see here? What do we see here? What is this and what is this? Okay, I'm actually doing it. It's not coming. Okay, there is the laser. Okay, thank you. So you see something here and you see a nebula here. Can you identify, do you know what these are? Yes, that is the Orion Nebula. And this is the Horse Nebula. Horsehead Nebula, sorry. Yeah, this is the Horsehead Nebula. I'll also show you some zoomed in or a different images that we have taken of these two nebula separately. I'll show that as we see later. So now coming to the moon and the planetary epi. See what we do here. So this is typically my first time. This is actually my setup. I use this setup to take images of some planets and the moon. I'll show you subsequently. And this is the telescope. This is okay. This is the telescope. This is a Schmidt-Cassegrain telescope. This is a telescope. And this, if you remember, somebody was telling that there is an automated telescope. We can just punch in the coordinates, and then the telescope will point directly to where we want to see. So this exactly does that. So here you have the remote, or say the built-in database of all the almost 40,000 plus celestial objects keyed. So you just have to punch in the coordinates, or you can even punch in the Messier catalog numbers or the NGC catalog numbers or any catalog number, and then we can directly ask the telescope to go there and check it out. This is also possible. I use this setup, and what you see here is an eyepiece tray. So all my eyepieces are here. So actually I was using this for visual. If you see, there is no camera at all here. So what we used to do is, here we used to remove this eyepiece area, and then we just connect the DSLR here, and then we can do the imaging. And of course, all the other accessories are mine and has no relevance to this image. Okay, this was taken by one of our fellow BAS members, Mr. Sukumar, and he used a similar telescope and used his phone, Samsung M30s, connected to the telescope. This is called lucky imaging. We put the camera on the eyepiece and then try to take the image. Okay. Yeah, just another view of the same from the same setup. Okay, this is the image of Saturn, which I took. One good advantage of doing planetary imaging is that you can do it even from the light polluted skies of any city. This was done from the center of this image was taken from Chennai with full light pollution, just like as we have it here. But I used a specific camera that's used for planetary photography. It's called the ZWO 462 MC, and the same telescope setup that I showed you in the previous photo, I used this one. There is a small double layer kind of a thing. You see that here on the edges, like something just you recognize this. Do you see this? Is it visible to you guys? Yes. It is because of the atmospheric dispersion. So since the light has to travel through the atmosphere, and the atmosphere has its own reflective capabilities, because of that, you see that the small thing coming over the image in itself. and it is not an artifact of the setup, or it's not an artifact that has come because of it. It's purely because of the atmospheric dispersion. Okay, and here we see that there are yeah, this is a Jupiter image that's taken by Strobel using a 130 Newtonian telescope. The 6-inch telescope just now what Vinay showed you, right? It works, it's the same telescope. And QHY 5, the 512 is the model of the camera that he used. So you see here, what all do we see here? Right spot, good. So this is the GRS. You can see here the GRS, the great red spot is here. And of course, something here. These are they some artifacts, or do you think they are something else? Yes, they are the moons, but I don't remember what they are right now. Okay, so he has got 2 moons, and he has got the GRS in this image. Okay, so let's talk a bit about DSOs, and I will show you the so far whatever DSOs we saw in the previous imaging were all from the wide field setups, right? So now I will show you something that's what we do is we kind of project or take images of individual galaxies, nebulas, and then try to frame it in a very closer, relatively closer shot. I will show you how we do it. So before that, we will see how what we really need for this. Okay, so and how why the setup is looking complex. So before we go into that, I'll give a small introduction and then connect you to that image where that entire setup is there. Okay. So of course, for capturing any image, what do we basically need? We need the camera, right? So here I have put two types. One is the DSLR in itself, and especially astro imaging camera. Of course, we can do astrophotography with DSLRs. There are wonderful pictures that have come out from DSLRs. But still, there are astrophotography cameras that's existing in the world for few reasons. Okay. What we know is DSOs are very faint objects. We all agree with this. We don't see it with naked eyes, even if you are in the darkest of places. We don't see all the DSOs with naked eyes. Of course, Andromeda is something we can see. Maybe Orion Nebula is something we can see, but not every of them can be seen with our naked eyes. Why? Why don't we see it? Let's say I am at the best of the skies, but I still cannot see Hassel Nebula. I know where to see, but I don't see it. Why? Yes, and it's very weak. The photons are very weak. They are very faint objects to see with naked eyes. Right? Unlike planets that you can just see it with your naked eyes, recognize them. It's not possible for all the DSOs. So the astro imaging so that means, what does it mean is, when we take an image of even with a DSLR, we have to do long exposures, probably expose the imager for 3 minutes, 2 minutes, 5 minutes, and then take an image. Okay, only then you see that the DSOs are coming as images to you. Okay, so for that, of course, DSLRs can also do it, but DSLRs are not designed for this. DSLRs are designed for portrait or any other normal photography, for which we will not set the exposure for 5 minutes. We don't do that in the conventional photography. This means the DSLRs will be, if we can still do it with the bulb mode that we have in the DSLR, but what happens is it ends up getting heated and it kind of generates more noise during this time. So these astrophotography, or say the special device, whatever I'm showing here, the image, the camera, this is also working in the same principle as the DSLRs. In fact, they have the same images that's part of the DSLRs. But the only thing is they will have additional cooling capabilities, meaning there'll be a fan, there'll be a cooling fan here, and also we'll have some seabed strips which will reduce the temperature. So we can bring the temperatures down to negative temperatures, -10, -15. We can control via our interface and bring the temperatures lower. This means that the thermal noise is really reduced. Likewise, there are multiple noises that will occur because of the long exposure, and the astrophotography cameras are designed so that they are capable of reducing that noise. That's why you see that there are special cameras for astrophotography. But does it mean that we cannot do anything with DSLR? Absolutely not. We all started with the DSLR, and then later and we found that we have reached the limit, and that's when we started venturing into astrophotography special cameras. Okay, now in order to collect the light, now the imager is where the light falls on, right? We have to put the, but how do we collect the light? Just like in the morning, Akash was mentioning about the light bucket, right? The more bigger the bucket is, more light can be collected. But on the other hand, if I'm able to keep the bucket outside for a longer time, that means I can collect more raindrops, right? The keeping it for the longer time is nothing but exposing it for more time. So what we are doing is, so that means that we will also need a lens, a conventional lens, the telephoto zoom lens is also okay, or a special telescope that we use for photography. There are again very similar to what I discussed about cameras and astrophotography, special camera. Telescopes also, and we have certain telescopes that fall into a category called as APO. Those telescopes will help us to align the colors in the same plane, avoiding fringes. So in an image, if we have you seen images in or I don't know, since we saw sun, I don't think you have observed it. When we see bright objects over binoculars, small normal binoculars, we will see fringes on the edge. The edge will have some coloration. If there is moon, the edge of the moon will have some colors like blue, green. But there will be a small tint. So in order to avoid this tint, probably during visual is fine. But if I'm exposing it for a longer time and trying to record this as images, then this fringe will become very evident and visible. So in order to avoid that, there will be color corrections done using multiple lenses inside, and this makes the setup a little more complex. And this setup is used for astrophotography. So that's why you will have special dedicated telescopes that's used for astrophotography. So we know that we need camera, we need a telescope, and of course we need the mount. So whatever I've shown you is exactly this mount what we have here, this white one, right? This holds that entire telescope, and this also helps us to track and rotate. So what we can do is basically as a when we do astrophotography, we kind of point the telescope towards north, align, and start tracking. So even the morning when we are seeing the solar activity, you saw that one of our setups, that setup was tracking, right? So we know that the Earth is rotating, meaning that if we wanted to expose it for 5 minutes and take an image, and if I'm not, if the Earth is rotating, then if I expose without doing any counter action, what happens is I don't get a clear image. The object would have, or say the celestial object, like say, or if you are targeting Orion Nebula, the Orion would have moved a bit. That means I cannot get a clear image. I will only get a moved image. So in order to counteract for the Earth's rotation, we will need a specially designed mount like this. This mount actually contains motors and has interfaces that we can connect to an external computer or a small Raspberry Pi kind of a device, and then we can automate the way it has to set up, and then we can make it track the object that we are trying to image. And that without this, exposing the camera for 5 minutes will not lead us to the beautiful images what we see. So that's the real need of this mount. Of course, the platform to hold the entire setup. So the platform to hold the entire setup. This is needed. This is right now what you're seeing in the front is a typical astrophotography setup. This is called a German equatorial mount, and it can, based on its payload, you will see small setups with a similar principle going beyond this size also, that can hold as payload, and then in order to have a larger light bucket, if you have a larger light bucket, larger telescope, then you need a larger mount to hold it, and then also control its speed, also control while it's tracking. So the mount also becomes bigger, that means the platform becomes bigger, and so on. Okay, now, and of course, to automate all this, to have a control over this, and start the imaging and targeting, we will have to have a PC or a small computer with us. And of course, for post processing, we will need a computer where also once we have the raw images, we can be at our home or comfortable place and do the processing of the image. So we will also need a computer as part of this setup. So this setup, what I'm showing you is the setup that I use. This is my setup. So if you see here, this is the telescope. This is much smaller than the one you see here. This is a Newtonian telescope. This is a refractor telescope, and this is the special camera which we spoke about. Yes, and this is mounted on a plate, and this is the one that is similar to this. This is from a different company, and it has a slight different principle in the way it works. Centrally mounted. That we don't have to go into those details now, but you have questions if you're interested to know what this is, please contact me. And there are some weights to counteract to whatever we are loading here. You can also see the weights here. It is also there. And do you see that I have two telescopes? This is one and this is two. Any guesses why we wanted to have the second one? And that's also smaller than this. Yeah, I heard somebody say guide. Yes, this is basically the guide scope. Okay, a finder scope, you use it during your visual astronomy, where you wanted to guide your actual scope. So a guide scope will basically be having a wider field of view. So if you are aligning the the finder scope with your main scope, and if you are able to locate a star, you will also see it in your main scope, right? Likewise, this is for the photography. So what it does is it does tracking, it does accurately try to track, but of course this is also a machine, and it is in real world we'll have a lot of tolerances, right? So that way the tracking could also go a little off, little here and there, but a little off here and there will also be clearly shown in the image. A little off meaning instead of showing the stars round, it will be showing the stars like an ellipse or something like that. It will not be showing it wrong. So it is very, very important that we drive the motor drives it very accurately so that we get a beautiful image or a very clear and crisp image. For that, this is not possible by, this is basically there for a feedback. This becomes a closed loop system. What happens is now wherever this telescope is seeing, this is also seeing the same place, but since it's having a wider field of view, it will be seeing more space. So I will lock a star, I will lock one particular position with this, and while this is trying to do the imaging, if it sees that, okay, I have to move 10 steps, but I moved only 9, if I'm missing one step, this will tell that yes, one step has been missed, and it will send to you, and then during this imaging only it will do a course correction. But basically this makes the open loop system. Can I do a imaging without this? Yes, definitely possible. But the thing is, you will not be able to get an accurate image. What it does is, if the entire system has a little bit of an accuracy issue during the imaging time, this helps you to course correct it during the imaging. So this helps us in overall, we get a better image. So that's the reason why I am mounting this. That's why if you see in the previous discussion, I did not exclusively talk about this, because with and without this, still it is theoretically or technically possible to do an imaging, but it helps us to improve the imaging significantly. Okay, and of course, like I told you, in order to control this, I have a small computer here, and this is just a battery bank to connect and operate this for the entire whole night. Again, this location is also from Coorg, where we had our BAS star party, and this was from December last year. Okay, and you see some strips? Here are some strips. There are two strips, this black one. Do you know what these are? Any guess? These are nothing but the dew heaters. See, we are in the middle of a jungle, and lots of flora and fauna around. So that means a lot of dew is getting coming up. There were days where we don't even see people little far off from us. So much of dew is there in the early evenings, and this dew heater, if this is not there, what happens? The dew comes and settles on the telescope. okay, and then this means that that completely blocks the light's entry. So once if you have a dew heater and this is on, this will give you a mild temperature. It will keep a small, I don't know, maybe around 40 degrees, something like that. It'll be all it'll keep the telescope area, that area in the warm. So that means that the dew will not come and settle in that place. So you'll always see that. So this problem of dew can be avoided. This looks like a simple piece of equipment, but if I go to Coorg and I forget this, I have to forget imaging. It's a very important piece of equipment, though it doesn't, if you convert that into value for money, probably it's one of the most valued equipment. Value for money, the unit makes the highest. That's a very important piece of equipment, and any piece of equipment is very important. You cannot forget this. You cannot forget any piece of equipment. Sometimes, if you are lucky, you get it from your fellow astronomers who are coming there. If you are not lucky, just close the box and look down. Okay, so that's typically about the setup. Okay, one of the best friends of astrophotographers, I would say, is Orion Nebula. Probably most of us, I cannot say all, but many of us, most of us would have started our imaging of nebula. That would have been definitely with Orion, for the very reason that it is easy to identify, and also it's bright. I think the magnitude. Any help with the magnitude numbers for Orion? Five something, around five. It's a bright nebula, and in a very good dark sky, you will be able to see its nebulosity with naked eye also. And in the binoculars, it looks fantastic. So that's the reason why most of us will start with this. And this is not my image, by the way. This is by one of our fellow BAS members, Ganesh. He's not here today. So it is with his image, with this setup. So the Skywatcher EQ6R mount is nothing but the model name of this mount, whatever you see here. This mount, this entire setup. And the telescope he used is an 81 mm refractor. 81 mm. The number means basically the aperture, the size of the light bucket, or say the dia of the light bucket. An 81 mm refractor is something like this. Same, this is also an 80 mm refractor, but whatever he has is a different from a different manufacturer. So this telescope on that setup. Also, do you remember we saw the Orion and the Horsehead Nebula in one image, in a wide field image? So these are the close-up images of that. So different setups can give you different field of views. Okay, so the bigger light bucket can give you a close-up field of view. So this image was taken by me with that exact setup what I showed you in the previous page. This image was taken by me. This is the Pleiades or the Seven Sisters. This image is from Subhendu. The only thing is the setup is not allowing us to see the image. Maybe become hot or what? This goes there. No, not this. How do I? Okay, this is remote, right? This is remotely done. Right? No, projector, no.
Okay. Oh, okay, okay, okay. Thanks, hold on. Agar, in the center. Okay, we will resume from playlist. This is where it dropped, right? Okay, we are still dropping. Yeah, this is playlist taken by Subhendu. Again, this is also from Cool, if I'm not wrong, right? Hanle. Okay, this is from Hanle. Next time I'll also add the location. So this was taken by Amber. This is called Thor's helmet. Like it looks like a helmet, right? If not, also you have to say yes, it looks like a helmet. So this was taken by a much bigger or a bigger setup than this. It's called an Ioptron Sen 70. Whatever I showed you, the setup which I had was called, it's called Ioptron Sen 40. This is a much bigger setup, and the telescope which we used is also a bigger one. It's a 10-inch SET, Schmidt-Cassegrain 10-inch telescope. That's a bigger telescope, meaning the payload is even bigger. And overall, it's a beefier setup than what we are used to. Again, the Pillars of Creation by Amber with the same setup. This one is by Subhendu. Or yeah. So this is the Andromeda. By the way, if you're all going.
Hello?
It's coming?
Yeah. Okay, let's resume. Sorry for that small break. So, like, yes, I have written Saturn Jupiter conjunction. So, what does this mean? That's in the sky, Saturn and Jupiter came very close. Does it mean that they have been close? Meaning, are they so close that somebody from Saturn can wave a hand and show it to somebody in Jupiter? Is it that way? You know, in the morning it was explained that they don't have to be in the same plane, of course, right? So in this image, they are coming in the same field of view. When I'm seeing from here, I'm able to see it in the same field of view. It doesn't necessarily mean in the other dimension it's in the same. So it could be like this, it could be like this, right? But when I'm seeing from here, in my 2D plane projection, these are the same. And that's what we see. And that's what we see here. And this was taken by Akash.
Okay, why is this special? There is a Jupiter and I've written transit, so that should make a link to you. But can you understand what this means? This image means. You have to clue in the topic itself. But yeah, let's give it a try. We have 3 moons, yes, and of course we saw the moons in the other images also, right? One of them is on Jupiter. Yeah, you see that shadow, right? So that dark black round spot, that's actually the moon that is transiting the Jupiter. So exactly when it was transiting, this image was taken. And by the way, with the Stellarium, you can zoom into Jupiter and you can change the time and see when this transit will happen, and then based on that you can plan your observations. So Stellarium will help you. Sky Safari or Stellarium. I think we use Stellarium in the morning. Yeah, Stellarium can help us exactly see this at what time this can happen, and based on that we can plan our sessions. That's how we end up in also making this image, because we know when this is calculatable, right? So it is on a path and it is on a velocity, and that means we can establish a function, and then we can understand when and where these moons will be. This can be easily calculated. So this is how. That's why this is special. Okay. By the way, this was taken by Obali. He's not here again. One of our BAS members. So this was taken by Keerthi. So do you know what this is? Of course, I wrote it on the top again. Next time I will see that I will read the topics first and then ask you questions. So this is Comet Neowise, taken from Paris, and you can see how beautiful it is. This again taken by Subhendu. So this was using the small simple setup. Where it is? Yeah, okay, we don't have it here. A small simple setup like just camera and a tripod, and you will, of course, if it's a solar eclipse, what's more important? You should have the solar filters different. As you had that solar activity, you saw in that big telescope, right? The Newtonian telescope, you had a silver kind of a foil on top of it. So that's the solar filter. So we have customized solar filters for camera also. So have to mount it in the front, put it on the tripod, aim it at the sun, and then use your intervalometer or something, start capturing those images, and you will end up with a barrage of images, and from that pick the ones that best suits for this kind of showing the transition, and then use that. This is also so this is the solar eclipse that we had in 2020. Is this partial or a full eclipse? Okay. That was easy, right? Which location was this, Subhendu, by the way? Bangalore only, no? See, Bangalore offers us a lot of... Of course, for, like I said, you have the right equipments, and if it is not cloudy, and at that point in time, if you have the planets coming up, planetary imaging is very, very well possible within Bangalore style image. You don't have to really go to a dark space for capturing planets. This makes it a little easier, or it makes it a little easier compared to what we have to do for DSOs. For DSOs, we'll have to spend 2 nights, 3 nights together, take those images and come to this level. But for planets, it doesn't really require that much of timing. Yeah, just the continuation of it. Now you see how it was done.
Subhendu, will you start from here?
Okay, now I will give it to Subhendu. Thanks for your time. We had some glitches, but yeah, we made it. If there are any questions, please feel free to ask any of us. You can also put it in the Telegram, or you can also, I'll be here, of course, until the end of the workshop. So if you have anything that you wanted to discuss, please feel free to ask to any of us. Thank you once again. Oh man.
MC.
Equipment is a big problem.
Issues. Just a quick introduction to Subhendu's work documents. He's going to talk about star trails. Once you see the pictures, you'll understand what exactly is a star trail, what equipments we are using it, and how to get it. So he's a software engineer by profession. As a hobby, he is into astronomy and astrophotography. So he's also recently got married. A little secret of his. So I got to know his wife gifted him a very nice mount to take nice pictures, which he's going to talk about as well.
This side? Start. Yeah, hi all. So I will be talking about how to take a star trail photo. So basically, star trails show how the stars are moving in the night sky. Okay, is it? Am I audible now?
Hello, hello.
Audible now? I have to speak closer. Yeah, fine. Next is this, right? Fine. So star trail image shows how the star is moving in the night sky. So you can capture a long exposure of it and then just stitch them together to see nice patterns. It's the same pattern, but yeah, it looks nice. So what kind of equipment do we need for this? So the first is just a basic, yeah, camera. That can be a DSLR or a phone camera also. Not something hi-fi astro cool cameras. And the second thing is that we need is a tripod, which will just stabilize the image so that the shots are in the same frame. So basically, we just follow some basic rules. The first thing is to frame the target. We can have a nice foreground object to have there. Huh?
In the back there, can we have a little bit of silence, please? Thank you, appreciate it.
Thank you. Yeah, so when we are framing the target with a for a star trail image, so we have to think about some nice foreground object. That can be anything. Some folks take it with some historical places or some object in the ground only, normal. So yeah, so first, one thing you do is just take some few test shot so that you can get some nice number of stars in a single image. And when you have got that, then you just take a lot of images and don't put a break in between the images. So you just capture lots of images. Let's say 200 or 300. How long you want to take the star trails? And there is a bonus tip is to reduce the exposure by a little bit so that the star will have a nice color to it. So right now I will just show a simple demo of how to post process the image and get the star trails.
showing there? We need to move the screen to the stop the PPT. Okay. Yes. Stop it or just end slideshow? End slideshow. Okay. Video. Now we need to put this rails into the screen. Just drag this. Where? Right. Drag it. So this is a free and basic tool which I have used. There are many of them like this, but yeah. So I will just. No, I need the mouse. No, mouse is there. But where will I put it? No, it will not work on class. Yeah, maybe you can have it the same one. Duplicate. Fine. Thanks. Okay, so after you have captured all the images, so we will just go ahead and stack them. So I will just use a sample from what I had captured long back. No. Okay. Yeah. So I have selected a few images from this one. Okay. Is it showing? Okay. Yeah. So I have selected a few star images like this, and to process it, I will just go here. Oh, sorry, it started already. Wait. No. Yeah. So there is some setting that we need to do. So first is just to change the blending mode to either lighting or gap filling, and there is an option of comet mode. I will show this in a separate slide. And yeah, after that you can just start the processing, and you can now see the star trails showing up. So you can see the stars are moving in this path. There is a nice curved thing. Can you see the foreground object? Can anyone say what that is? The foreground object. It's a dead tree. Yeah, so it was not lit up. It is not showing up very brightly here. But yeah, so if you see here, some of the stars have some kind of colors to it. Yeah. Can anyone tell what is that star color mean? Anyone? Please say it louder. Yes, the temperature and about the size of the star also, right? So the bigger stars will burn the gases very too much, and then it will light up brightly. So the blue ones are the most hotter ones. So yeah, let's go back to the presentation. So it's in the common mode. So this is the final image from that, the one that I was trying. So you can see that there are some of the blue stars are there. There are some yellow. There are some red stars. Can you tell me what is the star at the center? pole star. Why it is not moving like the other ones? Okay, because it's on the similar axis to what Earth is rotating on. So that's why it will appear to be fixed. Also, if I tell you that each of the star trail is subtending an angle of 15 degrees, can you tell me how long was the duration of the star trail? 1 hour. Nice. Yes. So this is one more image, star trail image taken by Snehith in Hanle. If you can see that you can see both sides of the curvature. So there is one in the bottom and there is one at the top. There are some stars with lights, but yeah, this is a nice image. And yeah, can you tell me what is this image? This on the left? Can someone say? So that was Venus. So this was taken very early in the morning. So Venus was just rising up here. This is one more. So this is where Snehith has tried to frame it with a pole star on a pole. So it's kind of funny. And on the right, you can see a small structure. So that is the Mace telescope in Hanle. So on bonus tip, so since you have taken a lot of, if you try, so you will have to take a lot of images for this one. So you can use the same images to create some nice time lapses. So one example of this is here with the same image. I can take some time lapses, which Mahadevan is very well known for. This is just a small one. So I talked about a comet mode in the So comet mode in that star stacks tool. So you can get the image and just have some different kind of time lapses which will look like this. Can someone tell me what's the big dense structure there in the center? Is this the one? Oh. Yeah, that is what I'm thinking. Yeah. This structure, can anyone say what that is? That's a star cluster. So a bunch of stars which are very nearby, and that looks like this. So yeah, with this I finish off my talk. I will give it back to Snehith for next one.
Thank you, Subhendu, for that. So one thing you understand regarding star trails is you don't need a fancy setup. So if you have your phone and a nice tripod, take the pictures of the stars, use the StarTax, which is a free software. You can do the blending mode or the comet mode, just like what you saw, and you can get these star trail images by yourself. So for kickstarting something that you would like to do regarding astrophotography, star trails is a good way to start with it.
Score 357. At least it will go till 4th day. Three days only. Yeah, today is almost. Just wait. No, just 10 hours left in the day. Maybe it will finish today only. If Bumrah just say.
You have a question? Yeah, go ahead.
Yeah. Sorry, can you be a little louder? As in, yes, so we have ways for it. So we can actually use a power bank to please continuously keep charging the batteries, or we get extra batteries. So once one of the batteries is done, just remove it, use the next battery to take the next set of photos. Yeah. Yeah. You can always use a double battery. So there is also a power source, as in you can put a dummy battery, connect a 12-volt adapter and put an extra battery which keeps running for the entire night. So there are ways to get out of it. But even if you, for the starters, if you have just one battery and run this, so mainly when you want a full circle of the star trails, maybe you need about 300 and 350 images. So even one battery would suffice for that. But if you're looking at something very specific and you really want with a nice capture and more trails to come up, yes, you need the second battery and you can start looking at other alternatives. But it is there, and that's how we do it as well. So you saw a lot of images when Raghul was presenting those deep sky objects, how this was taken and what is the equipment it is used. But there's one step in between that I just wanted to quickly run through. It's just really basic so that you guys understand. And if you really want to get into astrophotography, that's a basic and you can start continuing with it. So we have something called as Siril. This is a free software which is available for Windows and Mac. Install it. So the images that you have taken with your equipment, for example, what I'm now going to show you is something called as Andromeda Galaxy, which you guys are very familiar with. So the number of images that you have taken from any particular place, you're just going to store it in one particular folder in your computer. Remove the ones which you don't like, as in some might be out of focus. There might be extra lights that is coming up in those pictures. Just remove them. Keep the ones which you feel like, okay, this is the what I'm trying to go into process about it. So what this Siril software does is, so if you have about 300 pictures, each picture it is going to keep one layer on top of it, and it keeps on adding. So this process is called stacking, and that is where you can see more colors of your images. So there were a lot of people asking where you see this red, green, and all those things. This is because of the amount of data that is being captured in your images. So no matter how many images that you take, the more number of images, the more number of data, the picture and the colors will be better. So I'm just going to run through an example of what we're going to do with this software. This is a Siril. So this is, when you open Siril, this is the basic layout of it. So don't worry what is there, what is not there. It's something that we can all explore. Okay. So there are multiple softwares to do the stacking as well. One of that is Siril, so it's free. So that's the reason why we picked this up. So Siril has something called as pre-rolled scripts. So if you drag it down, you can see the options that are available. So I'm just using one of the scripts which is called as pre-processing without any dark, blast, and flats. So I don't want to go into any of these details, but if you have that questions about dark, blast, and flats, we can always discuss it later. You just click on this and click on run script. So you can see that the process of stacking is already started. So it says converting and processing 74 files. So this is basically, this software is adding each file, converting it to the format it wants and stacking it. Within the next couple of minutes, the stacking will be complete and we'll have certain image. So once that image comes up, I'll take you further through how to get the colors and how you'll see the final images that you guys saw in PPT. So in the meantime, once this is running, if you guys have any questions, please shoot so we can discuss about it. Yeah. So this is a single raw image taken from the same DSLR, which you can see on the stage. So about 300 images is what I have particularly selected, the ones which are nice for me.
But for stacking purpose, I've just used about 74 so that it's much more faster and we'll get the final image to do the processing. 30 seconds. No, this is a RAW image, full RAW image. It's not stretched. Yeah. Sorry? Pointer is not working. It is even more. So can you see the other galaxy over here? Right there. Just go back to Siril just to check if done. Halfway through. Any more questions? Yeah.
I just want to ask a opinion from your side.
Okay.
How do you feel about the universe is expanding? So in further future, every star will disappear from the night sky. So how do you feel about that? How do you view on that?
If you're asking a personal opinion, I don't think so. I'll be there to see that. So I'll really not know what's going to happen. Yeah, it's if you're looking at a personal opinion, I think it's going to be really tough going for the further generations as to what they're going to see or what they're not going to see. So that's the reason why everything is captured, documented, or even the visual spectacles has been. Yeah, Akash.
Can I add to that?
Yes, go ahead.
I mean, if light pollution grows like it is,
we won't see anything else. No, there won't be a section. So that's the reason everything is getting documented. So as in pictures, as in what are the data that is coming in, even the visual astronomy folks have their own data sets where they mention what they have observed, what they have not observed on the night sky. So that is the only way to represent going forward if the way this is going to continue. So the better laptop and the better processor you have, this becomes very fast. Considering if you have a very slow laptop, it takes a lot of time. This is a free software, yes. Siril is free. So the console actually shows what exactly it's doing and which picture it is trying to stack. So if you observe carefully, it will give you the image number as well. You can see that light 0014 is the 14th picture that it is picked to do the stacking. Has anybody tried stacking or done any astrophotography before apart from the BAS members here? Anybody? Okay, is this something familiar to you or this is? Okay. Okay. Phone to stack. Okay. Great. Great. Yeah, BAS is another software as well. Okay. So DSS is quite commonly used. But the reason why to bring in Siril is this something has a preloaded scripts where you don't have to break your head. So if you have all the materials and the photos in the particular folders and you run the inbuilt scripts which is there in Siril, it will do the stacking for you. Once you have the TIFF image or the final image, then you can play around with it to bring the colors and all the edits that you need. Yeah. Yes. That everything the software takes care. So basically these images are tracked. So I have not, it's not just with the DSLR image, it's already tracked because this image will be in the same position as in the Andromeda Galaxy or anything will be in the same position for all the pictures. But otherwise also the software is good. The reason you've asked is in case if there is a shift in one of the images, it will calibrate by itself. That's what the script does. So it will tell you the angle that it has shifted for the next picture, and it will say it has moved it back to where it has to stand.
The process is called
Registry.
That is also done by
Siril.
It's called registry. That's also done by
So it's showing there, right? See, global star registration processing.
Ross.
So it is also rejecting certain pictures which are not aligned. Can you see that? Yes. So the other advantages of using other softwares which is also available are it has different approaches and different ways of doing it. This is much more easier. All the astrophotographers here know that we only collect the data, but we don't do post-processing. So we wanted to show something which is easier so that you guys can do it as well. So there are multiple paid softwares as well. One is Sequator, and you can also use PixInsight, which has been widely used by all the astrophotographers now. It's here. I should have taken probably 10 or 20. Then wanted to stop it. Almost done. Another 5 minutes.
The presentation that I sent you yesterday, which showed how an original image looks like and how the stack looks like.
We didn't transfer anything into RPT. We're almost done. But it's rejecting a lot of images. I don't know why. Yeah, that we had cut short because of time. That's okay.
When it is running this, maybe you can show that.
We didn't put it in the PPT, but that's the whole PPT which is there by Shankar. No, that's okay. Which one? Which is in the folder? It says script execution failed. Forget it. No, I don't have that because it was there all in my network. Do you have any stack limits? Not it. Maybe it's okay. We'll show that Andromeda file.
In this presentation, do you have?
Yes, yes. No, as in, yeah. But Andromeda is final images. So, okay, let's put it to. So this is what the stacked. Okay, sorry. This is exactly how the stacked image will look once you have processed in Siril. So it has some particular options to increase the colors, the histograms. We can always play around with it. If you have any questions, we can bring it up. To cut short of time, I don't want to go into processing where how what, but once you do that basic processing, this is the final image that you get. And based on what the output you want, the colors you want, you can always bring it out. Any questions before we move on to the next talk? Okay, I would like to. The next talk is about the astronomical journey by Dr. Akash. So he currently finished his PhD in physics in Texas University from US. He's back to Bangalore now. He's been the pioneer of BAS and also the founder member, and currently pursuing in his hobby in astronomy. And he's also built some telescopes by himself. He'll walk you through the journey, which would be really inspiring. Hope you guys enjoy. Dr. Akash, please. Which one is your?
Okay, I'll pick it up.
This
mic is, I need the live stream mic. Okay. Won't it be able to fit the mic?
I'll put that.
Okay.
Yeah.
How do I open the PDF as a full screen? Control Shift F usually works.
No,
this is not a nice viewer. Why don't we open in Adobe Acrobat? Yes, open with Adobe Acrobat.
This one.
Okay.
This is the keyboard.
Okay. Control Shift F. Will that full screen it? That did not full screen it yet. Oh, it's not Control Shift F. Control Shift B, presentation, F5. Which one?
Let's try this.
Just try maximize. Okay, that's a progress. Keerthi, do you know how to full screen in Adobe Acrobat?
F11. That's what I also tried. Okay, so let's try this.
This is technically full screen enough, and I can just use it.
Yeah. Here it should be.
Okay, great. Thank you. Okay, so I was asked to give this talk about my journey in amateur astronomy. So even though I got my PhD in physics, the astronomy part is completely amateur. I'm a hobby astronomer. I was asked to give this talk to tie up with various fields and how you can get deeper into this hobby if you're interested. So I've done a little bit of astrophotography, a little bit of telescope making, but by and large, I'm a visual deep sky observer. So very little planetary observing as well. I've not done much planetary work. So, so I'm going to take you through my journey. My journey in astronomy started with a software called K-Stars. And it's an astronomy software like Stellarium, the one you used today to explore the sky. So this got triggered in me because I was tinkering with Linux. I was more into computers back then than into astronomy. And I found this software on my Linux installation and started getting excited about it. And so then I started looking at the constellation patterns on the software and going up and looking at the constellation patterns. And there were all these cool names like Orion Nebula and Beehive Cluster and Jewel Box Cluster and all of that. And I really wanted to see these things, but I didn't have the means, no telescope, nothing. So what did I do? Well, I luckily came across a sister association here in Bangalore called the Association of Bangalore Amateur Astronomers. They've been around in here since the 1980s. They're a very old club, and they still meet regularly on Sundays. In fact, I'm giving the talk there tomorrow on my 28-inch telescope. And I joined ABBA in July 2004. This is before BAS even existed. And there's my membership card. Yeah, so at ABBA there back then was really known for telescope making. They used to know how to build 6-inch and 8-inch telescopes, sort of in the from a very different construction from what Vinay showed you earlier. But this is the basic grinding process and all was the same. So I actually ground that mirror, and I learned that I will never grind a mirror again in my life. Then finally, after about a year of effort and a lot of help from the then president of ABBA, Mr. Dilip Kumar, I finally finished this telescope. And this is a 8-inch telescope on a German equatorial mount, like a manual version of that, like we were using to view the sun earlier manually. So this was really what opened up the night sky for me. Back then we didn't have fancy ways of pointing. All we had is the tube, and all the only eyepieces we could afford were these cheap plastic eyepieces made either in China or India, but from Tedraj and company. We didn't have these nice Plausible eyepieces and so on that we have today. So whatever we had, we used to make do with. And uh, one more person at ABBA gave me this inspiration, saying, now that you've built a telescope, don't let it gather dust, because most telescopes, believe it or not, gather dust, not photons. And so he said, you really should do something with your telescope now that you've built it. So I told myself I will see all 110 Messier objects within a single year of getting the telescope. So by 2006, I should be done with the Messier catalog. That was my aim. I tried to do as much as I could from the rooftop of my house. Back then, you could, in 2006, you could see the summer Milky Way, just the brightest patches from RT Nagar, which is where I lived back then. Today, it's unimaginable, but back then you could do a little bit of deep sky work from the city. So I did do a lot of open clusters and all the bright stuff from the city, and then on the right is my log. Remember, Gautham talked about people keeping logs. That is my log entry from 2005, I think, sometime late in 2005, that talks about my first trip to a dark sky site and what I saw and so on and so forth. So I have notes back from 2005. I have a dark period from 2007 to 2009 where I don't have notes, but the rest is covered. Once I had this telescope, and once I met one of my observing buddies, Amar Sharma, who knew a lot of dark places. Me and Amar Sharma developed this partnership of going to our local dark site, which we had found near Dodbalapur in a village called Hosaldi. The best part is it was bus accessible, so we could leave my telescope in the government school premises there, and we would just take the bus to go and then pull out my telescope and observe, and then we'd put it back and come back by bus. So I didn't know how to drive. Even today, I can't drive in India. But because of bus access, we were able to spend at least 30 nights there. The bonus of this place was we knew about the school because Mr. Dilip Kumar had donated a 8-inch telescope to the school. Somebody had donated it and he had made it for them. And so we also had access to the school's telescope. They'd let us use it. So sometimes we'd go there without my telescope and we'd use the school telescope and all of that. But we did a phenomenal amount of observing here. Then at that time, BAS had just started, and I was heavily involved in BAS. So these are some early examples of BAS star parties where we had a banner at the back of a bus and we went places. The top one is at Yeligiri in 2006. And I was also active in my college astronomy club, the IIT Madras Astronomy Club. So that's a picture from the right. And many a time we used to meet in the middle in Yeligiri. So BAS folks would come from Bangalore, and the Chennai folks would come from Chennai, and we'd meet in the middle. It was very nice that we had several star parties like that. This was 2007, 2009, and so on. While I was at IIT Madras, I really wanted to try astrophotography. Back then, deep sky astrophotography simply was not being done by anybody other than one person, Dr. Suresh Mohan. He was probably India's first deep sky astrophotographer, as far as I know. And he lives in Chennai, so he was very close, and we learned a few things from him. I did my first planetary imaging and a little bit of deep sky with his help. And here you can see me put a DSLR to a Newtonian scope, and with my laptop, I'm trying to image. But I quickly realized imaging is not for me. There are too many technical challenges to be overcome. You see, all my stars are not round. Nothing is. The images are noisy. You know, any astrophotographer who looks at this will say that's junk. So that's where I stopped. But I was still observing. So I observed almost 250 objects with my 8-inch. And here's the list of various objects that I had, and I would check them off without much logging back then. But around that time, I was hit by aperture fever, unfortunately. So I started saturating my 8-inch, me and my friends. So we were really looking for what's next. And we found this website called Adventures in Deep Space. Okay, this has some really challenging observing projects that you can pursue for not just one lifetime but 2 lifetimes. So if you believe in reincarnation, you can try and be reincarnated as an amateur astronomer to finish all of the projects here. But there is one man who can do everything in triple speed or quadruple speed. His name is Steve Gottlieb. In his lifetime, he's 75 now. He has observed 23,800 objects, okay, and kept meticulous notes on every one of them, okay, and he was the inspiration for us. We used to read Steve Gottlieb's notes back in 2009 on this website, and that's the guy on the right here. This is Steve Gottlieb. Yeah, we used to read his notes and we were just fascinated by what all he had to say. He wasn't, I mean, most of us look at Andromeda Galaxy. People like Steve Gottlieb and his friends were looking at globular clusters in Andromeda galaxies, nebulae in Triangulum Galaxy, nebulae in NGC 2403, which is some other galaxy. So those are the sort of projects that these people were doing, and we were very inspired. So we noticed that Steve Gottlieb started was observing heavily with a 17.5 inch. So we decided that if I got a 17.5 inch, I would be able to see the same things, or we hoped. So that's where it started. I convinced my father to get me a 17.5 inch, and he did. It was very expensive, and he was very generous. So this was imported from California. It came, so one March in 2009, I got 3 huge boxes shipped from California. And you can see myself, my cousin, and the past president of BAS, Naveen Nanjundappa, assemble my telescope and set it up for the very first time in RT Nagar and look through it. That may have been at one of the largest telescopes in this area, that's amateur telescopes in this area back then. So we took it to a lot of BAS star parties. Here's its first light, which means the first time we took it to a dark place and observed with it. This is also at Hosahalli near Dodbalapur, and it was during a BAS Messier Marathon event. On the ladder is my observing friend Amar Sharma, and I will never forget the look on his face when he saw this telescope. He had no idea it was coming, and he had planned a Messier Marathon. I had given some excuse saying, Messier Marathon is where you observe all 110 objects in the same night. It's possible. I've not done it. I've never succeeded. So he had planned a Messier Marathon for BAS, and he said he would observe, as many Messier objects as possible in a single night. And instead, I came up with this giant telescope later and thwarted all his plans. But he was very happy. So later in 2009, December, so that was March 2009, in December, we took this 17.5 inch telescope, which was really, really something we were amazed by, to a truly dark sky site in Coorg, So in Coorg, we took this in December. Keerthi was there. I think nobody else in the audience was there. So Keerthi, I, and a few others took it to Coorg, and we did all sorts of things that we never thought we would achieve. We looked at Andromeda Galaxy, and we were not just able to see the galaxy as a fuzzy patch. Okay, I'll just point with my hands. So we were not able to see we were not just able to see the galaxy as a fuzzy patch like we've been describing, but we were able to see these 2 dark lanes, giving it its 3D structure, right? So we were able to see the galaxy, and we were able to see this. This is a cluster of stars in Andromeda Galaxy. We were able to see it, okay? And we also later found a globular cluster in Andromeda Galaxy. So globular cluster 2.2 million light years away. So we saw all of that for the first time. We also started seeing structure in galaxies. So there were no longer these faint fuzzy patches to us. We started seeing spiral arms, and that's one of the toughest Messier objects in the center. And we were seeing spiral arms in it. And Horsehead Nebula, we have discussed it many times. It's good photographically. It is very challenging to observe visually. And we were also able to finally observe that. So lots of dreams came true in December 2009 with the 17.5 inch. So after that, I had to move to the US for my PhD. So my time with the 17.5 inch was short-lived. Maybe I used it for like 10, 15 nights where we used it heavily at all BAS events. You know, there used to be a lineup at the 17.5 inch and all of that. But I moved to Texas, so I left the 17.5 inch here. I had no idea how to drive. There's no Uber is there, but there's no intercity. You can't just take a driver and go to the dark sky site in the US. So learning to drive was a prerequisite. So that had blocked my progress in astronomy for a while. I also didn't have a telescope. I lived in an apartment. I still do live in an apartment. And managing a telescope, a big job in a big telescope in an apartment is hard. But yeah, I luckily met this person on an online forum on the right. His name is John Tartarchuk. He's not very active in astronomy right now, but he had a 25-inch telescope. And he's not a dwarf. The telescope is really that big. Yeah, he took me out. Various generous people took me out to my first dark sky site almost like 2 months after I landed in the US. And I also met him. He was a student at my university. And I observed many nights with him and his 25-inch, and he taught me a lot. So we developed an observing partnership that was very fruitful. And he also sold me his old 18-inch for a very good price. So he had upgraded from 18 inches to 25 inches. By the way, when I say 18 inches, by now I hope it's clear, it's the aperture, the size of the light gathering bucket, if you like. And so it's 18 inches diameter, the mirror, right? And yeah, I also learned to drive eventually. And this picture is at an observing site in Central Texas, which was very, very good. I missed that site. It was really, really dark. So some BAS members also have migrated to the US. So there's really a joking group that I started called BAS California chapter. But it seems more and more serious every month. So Hemant, the founding president of BAS, happened to also move to Texas. And I didn't know how to drive back in 2012 still. And he knew how to, and he drove us to Texas Star Party. He, his wife, and me. And this is his astrophotography setup and my 18-inch. And that's him hiding behind, I don't know what it is. It's too, you know, back then phones were not, or cameras were not good at exposure. But yeah, we had to learn a lot in this trip. We had to learn how to camp, cook vegetarian Indian food in the middle of some ranch in Texas. And thankfully, Hemant and Jaya figured all of that out for me, and I could just observe. So this is me with my telescope there, and that's my logs. I got to see a lot of cool things for the first time. The spiral arms and the galaxies were just incredible because of how good the sky was. This would back then be considered one of the best skies in the country of the USA. So it was really good, and I could go very deep with my 18-inch. Now 2 years later, another interesting thing happened. Of course, I talked about my experiences of Texas Star Party on BAS and others. And a 14-year-old BAS member decided to come to the US specifically to attend Texas Star Party. So in his visa interview, he said that I'm going to go and go to a star party. And the visa officer said, "What? You're going to Hollywood stars in having a party and you're 14, you can't even drink?" He said, no, this is an astronomy event. And then they asked him about some astronomy questions just to make sure he's telling the truth. And they quickly granted him his visa. So that's the story. And there he is, there's Santosh. And also there. And in the bottom right, he's actually standing with two of the best visual observers of the world, who are very. The person on the right is living. The person on the the person on the left is living, and the person on the right, Barbara Wilson, she's no more. But they are really good visual observers, some of the best. And everyone loved Santosh. They thought it was crazy that 14-year-old from India would travel to Texas specifically for Texas Star Party. And so he got all the gifts. Everything that people won in the lucky draw that they didn't want became Santosh. But Santosh did something really good for me. And he pestered me to message a person who lived near Texas Star Party who had a 48-inch telescope. 48-inch, 1 meter, actually 1.2 meters or something. It's bigger than the one of the telescopes at Kavalur Observatory. Okay, gigantic telescope, personal, amateur. Okay, so I ended up messaging him for Santosh's sake, and he thought it was cool too that a kid would come all the way from India, and he had also read my observing notes on various forums, and he said, "Come over." So we did, and that's me standing on his ladder. I don't know how tall his ladder is, and that is his telescope. Yeah, and the first night there was cloudy. So he said, so he just showed us Saturn through the clouds and said, well, it was cloudy tonight, so you can come back tomorrow night. And we were jumping, okay? So both of us went back the next night, and the night was clear. And my goodness, we saw some really cool things. Hoax object, a ring galaxy, 7 Zwicky 466. Have you even heard of a catalog called Zwicky? Okay, so there's like really cool objects that we ended up seeing through that 48-inch, and that fostered a friendship between me and Jimmy Lowry that lasts till today. We are very close friends, and I'm very fortunate. It's been a very good observing relationship, and also friendship outside of astronomy. And I'm very fortunate that I got to observe through that beautiful instrument almost 30-40 nights by now. It's really an amazing instrument. Anyway, when I visited in May 2014, Jimmy Lowry told me that your hero Steve Gottlieb is coming here in October. I said, can I come? Okay, and yes, he said, yes, you can come. And I drove 7 hours for, without thinking, to go and observe with Steve Gottlieb. So I finally met Steve Gottlieb, who had been my inspiration and mentor through the internet. And we had a very good time observing. We observed one of the most cool things we observed that day was a shell galaxy, where there are shells and some really interesting structures in it. It's a very cool galaxy. And then I learned a lot from Steve and Jimmy, and that's a BAS t-shirt I'm wearing. Okay, anyway, so in the intervening years, almost 10 years since all of this, I made many observations over the years through my 18-inch and also through Jimmy's 48-inch. And I keep logs like this. This is my spreadsheet where I say when I observed what and what I've observed. There's about 1,500 entries there, but the total number of objects is higher because some of these are like galaxy clusters and things like that. Okay, so now I'm going to switch gears and talk about recent times. So this was a cool observing trip that we took to the Nevada desert. I later upgraded my vehicle because I realized that carrying a big telescope and even bigger telescope requires even bigger vehicle. So aperture fever doesn't make you just buy big telescopes, it also makes you buy big vehicles, so beware. So it started out, so I had an observing trip to the Nevada desert, which is very barren. I think the nearest city must have been 200 kilometers, and the nearest small settlement must have been about 70, 80 kilometers from where we were. So really no cell signal, no water, no toilets, nothing. We had to carry everything in and dig holes in the ground. Literally, yes, I'm not joking. So there's only one other person that's crazy enough to do, no, there are few people who are crazy enough to do this with me, but there's one person who is also ready to do it in 5 minutes, and that is a guy from Mangalore named Tarun Kotari. So he came with me, and he's an astrophotographer, landscape. He took this beautiful picture, and what I'm doing there is I'm doing a 2-hour exposure with my eyes on something that you'll see in the next frame. So that's the result of the 2-hour exposure with my eyes. So just like they told you that in imaging, you have to integrate over really long times. In visual observing, it's not integration, but you have to observe over really long times to get all the details. So I was exposing Whirlpool Galaxy with my eyes and sketching, taking notes. Almost everything was unprompted by an image, except I think this detail. I had to look at an image and then look into the eyepiece and said, oh yeah, it's there. So some of my trips like that are vlogged on my YouTube, which you can look at. They're not very good vlogs, and I stopped doing editing videos after a certain point. Okay, so that's one recent trip. The other recent thing that has happened is I did it again. I fell prey to aperture fever again. and I went from an 18-inch telescope to a 28-inch telescope. Thankfully, I got a good price on the mirror because my friend Jimmy Lowry, the same person with the 48-inch, he sold me his old 28-inch telescope. And it lacked one component. It lacked this component, which everything rests on. So unlike Vinay, I didn't have to do any calculations for truss tube lengths, and so those were all figured out. The mirror was done. Most of the structure was done. I just had to create this one thing. But I have very little DIY experience. So I had two great friends helping me. So here you can see one of them. He's very experienced in making telescopes. So so you can see there we are testing the movement and trying to align the bearings on which the telescope rides. And there I'm actually manually filing a bit of a plate that attaches my focuser to the telescope. But in the end, we had 3 weeks to finish this project, and in 3 weeks, we restored that telescope and took it to a star party. I have now used the telescope for only 5 nights, so I'm really looking forward to using it more. The problem with the telescope is it weighs about 150 kgs total, and the heaviest component weighs about 75 kgs, so I need 2 other people to help me lift it. That needs to change. I need to be able to go observing alone, and that's what I'm working on. So the views through that 28-inch are incredible, especially Swan Nebula, Whirlpool Galaxy, and Hercules Cluster. Swan Nebula was very, very mind-blowing. Eagle Nebula, Pillars of Creation, mind-blowing. I never expected the jump from an 18 to 28-inch to be that large, but it is. So I'm very excited to use this telescope more. In around August, more recently, I published an article in the Sky and Telescope magazine, October 2024 issue, which Shashi has kindly put up for you to see. My request is please do not take photographs of it. That's instructions from from copyright law basically. So please respect that. But you can read the article. I also happened to summon the courage to put my own sketch of Rosette Nebula, which, of course, when you sketch something, you're always like, is this good enough? I don't think it's good enough, but I submitted it anyway. I took a lot of inspiration and support from Howard Banich, whose sketches you've seen before in the visual observing talk. So that's it. What are my future ideas? I won't leave astronomy yet. I have another Sky and Telescope article coming up. I hope to motorize the 28-inch and make the 28-inch a one-person operation and do more observations with it. And those are links to my work. On the left is my website, which has my talk, slides, videos, whatever. On the right is Adventures in Deep Space, the website that inspired me. I ended up becoming the webmaster of it, so now I have the chores of putting up observing logs and so on it. So I also have some writings on Adventures in Deep Space now. So that's it. The reason I was asked to give this talk is to connect up what a journey of an amateur astronomer looks like, given all that you've heard technical stuff from the morning. So hopefully it's been useful.
We have an internal bet that Akarsh is going to upgrade to 40-inch pretty soon. Internally, BAS, we have an internal bet going on.
No.
We are going to win it.
No, I've kept my 18-inch for 12 years. No, 13 years almost. So, so 28 should last much longer. Okay. Should I? Do I have time for questions? Okay, I can maybe take questions for 5 more minutes. Okay.
Akash, really thank you for this talk. I hope some of the participants and students take something out of it and start doing the same kind of logging and experiment in astronomy and visual astronomy like you did. So if you guys have any questions to him, we might take a couple of questions, so please shoot it. So
there's some question there.
I can see two of the hands raised. Do you guys have any questions? Okay, even if you do have any questions, he's sticking around for some more time. You can just walk up to him and ask him questions. So I also wanted to thank Akash because he's not just into visual astronomy, but he's also a co-developer for K-Stars. That's in Linux-based planetarium software, just like how you saw Stellarium. That's been co-built with his one, and he's also written multiple. What do you say? Blogs that you can follow. You'll be really inspired to see that the conditions that these guys go through, anybody for doing an astronomy and how they did it. So you will be able to get, okay, some idea like, okay, this is what you're going to do and this is what we are going to get. And at the end results of what you're seeing is already being presented there. So now I call upon Keerthi to discuss about how general public can contribute about astronomy. He is the current trustee of BAS. He is also keenly interested in astrophotography, so we have learned a lot from him as well. And he's also a principal architect who's working on ADAS, that is the autonomous, how the vehicles move, just like how Rahul was doing. So Keerthi, the stage is yours.
Yeah, thanks Akarsh for the wonderful talk. So my talk is very short. Okay, so hi everyone. So now we are concluding the sessions, right? So from morning you have been hearing a lot about astronomy, especially amateur astronomy. Okay? And so as amateur astronomers, we are probably failed astronomers, right? I mean, we did not become professional astronomers, but we took this as a hobby and we continued this as our hobby. And but then we also use a lot of scientific and engineering techniques to do the stuff that we do. So let's say, for example, Snehith talked about how so let's say, for example, we don't have professional equipment, but still if you want to get good images, how that can be done, that was shown. And also how do you actually see these objects, right? So there are a lot of professional astronomers who are studying many objects, but they wouldn't have seen the object even once. And here we have Akarsh, who has seen thousands of objects through multiple big telescopes, and a lot of us have also seen a lot of objects. And in the morning, even our Pramod was saying that there are some students who are doing some research on sunspots, and they saw the sunspots for the first time here. So this is a very rewarding hobby. So as a hobby, this is also very rewarding. And if you guys are interested to continue this hobby and also to learn more about astronomy, how can we do this? So there are a lot of really nice books, and these books were recommended by Shashi. And so for astronomy, we have this The Cosmos, Astronomy in the New Millennium by Filipenko and Pesakov. This is a very nice book. And also we have Universe by Friedman, Geller, and Kaufman. And if you want to pursue visual astronomy, so you want to see many objects, there are a lot of different techniques to see the objects, and if you want to learn more about that, so we have this astronomy hacks, tips and tools for observing the night sky, then Visual Astronomy of the Deep Sky by Roger and Clark, which is a very nice book, and also Starware, the Amateur Astronomer's Ultimate Guide to choose and buy and use the telescopes and accessories. So there are a lot of really nice books, and through this you can learn a lot on what kind of objects are there, how to observe them, and what can we learn by observing them, right? So basically, after observing, we also want to understand what is going on in those objects, what is the physics behind those objects, and all these books will give us that idea. And if you want to do astrophotography, there are also very nice books. Also, there are a lot of YouTube channels and resources available through YouTube and other websites. So one of the best books which I had not read, and Shashi showed it to me today, that's the Deep Sky Imaging Primer by Charles Bracken. The other two I have read and they are also very highly recommended. Astrophotography by Thierry Legon and Digital SLR Astrophotography by Michael A. Corrington. So back in 2010, when I was starting astrophotography, I read this book and it was a really nice book. So you really understand how a camera works and how we can make the best use of the camera to do astrophotography. See, all these cameras are not really built for astrophotography, right? So astrophotography modes we may have in some of the new cameras or mobile phones now, but then these are not made for serious astrophotography. So you need to do a lot of tinkering. Maybe you have to do some modifications in the camera. You have to use certain softwares to take all these long exposure photos and then process them and so on. So there are a lot of things like this involved, and these books will give you that idea. Also, there are very nice forums. So BAS has our own website, but our website will just give you the links to all our discussion forums. Like we have a group in Telegram, and we have a group in WhatsApp, and so on. So the Telegram group is the most active, and also we have a good Google Groups, which is not so active, but it has like from 15 years all the discussions that have been happening. So those are available in the Google group. So BAS website and our Telegram channel are one of the best sources to know what is happening and how you can pursue this. And if you have some questions regarding how to use a telescope or how to use, let's say, your camera and so on, you can always come there and ask us, like where to go. So all these questions can be, you can come and discuss with us on our Telegram. So if you go to this bas.org.in, you get links to all our communication channels. So apart from this, there is Cloudy Nights. So yeah, we have cloudy nights now, right? I mean, we don't have cloudless nights. So whenever you can't go out and observe, you go to Cloudy Nights forum and then you start discussing over there. That's the idea. And there is also Adventures in Deep Space, which is also now managed by Akarsh. Akarsh, you are managing this one, right? Adventures in Deep Space. So this is also a very old forum now being managed by Akarsh. And also we have on our YouTube channel, has a lot of really nice resources which are not available in any other channel. So you could also visit our YouTube channel and learn more about astronomy and astrophotography. So if you want to pursue astronomy as a hobby, then these are all the resources that we have. Now Sundar will take you through, I mean, he will talk about pursuing astronomy professionally, and yeah, how you can proceed in your career in astronomy.
So good evening, everyone, and yeah, we meet again. I met you at the beginning of the session, and I'm meeting you at the end of the session. So all the efforts of others, I get to take the credit in some way. Thank you. Part of the reason why I started with that statement is because I started my journey as a student just like you in one of the sessions of BAS back in 2008, and BAS was just young infant trying to figure out how it should take astronomy ahead back in those days, with many of the senior members who are not here right now except Akarsh and Keerthi. But yeah, my journey began like that, and eventually the interest grew into me becoming trying to become a professional astrophysicist. Okay, I wouldn't say I've become, but it's a journey. So I'm trying to become a professional astrophysicist, and that is the whole reason why Keerthi, Shashi, everybody asked you should be talking and you should tell how to go from amateur to professional. My initial apprehension was probably there wouldn't be too many students, so
let me skip this session and run away from the audience and me talking. But it so happened that there are more students present here, and given the fact that there are more students, I thought it is better I speak very briefly as to what can be done and how you can take things forward. And if you are a parent, if you know somebody who has an interest in astronomy and how you can guide them into taking up astronomy and astrophysics is something that I thought I'll briefly discuss. So the first starting point, in my opinion, would be to start off like how all of you have started, by attending workshops and sessions and talks like these, because these give you an insight into a lot of jargon. So today you heard a lot of new jargon, probably which you have not heard in your life before. Astrophotography, visual observation, sunspots, prominence, mounts, filters, not the aquaguard one. So a lot of new things you heard. So these sessions will kind of initiate you into listening these words or hearing these words and then taking it further and kind of kindling that interest in you. And furthermore, if you are inclined academically, there are basically two routes that you can kind of take into becoming a professional astrophysicist or an astronomer. The first is the sciences routes, assuming that there are some BSc and MSc students here. So you do BSc with physics and maths. Yes, you cannot run away from these two if you want to do astronomy. And probably do MSc, preferably in physics or probably in mathematics as preferences. And then eventually you can take up research as an option. And then you can get into a research institute, pick one of the topics that all these people have mentioned. They have mentioned sun, they have mentioned star, they have mentioned nebulae, they have mentioned galaxy, they have mentioned Milky Way, they have mentioned umpteen number of objects today. So you can pick any one of the object and start your career in that. And at the same time, you have also heard them talk about telescopes, mostly visual. But astronomy is one such domain in science which has options across the entire electromagnetic spectrum, starting from gamma rays up until microwaves. Okay, so you can be an expert only in one domain. For example, there are experts who say, I know only radio astronomy. So they don't know anything else. Anything in radio frequencies, they are the experts. And then they say, even in radio astronomy, I only study galaxies, nothing else. So they are what is called as galactic astrophysicists who are working in radio frequencies. So the level of expertise that you can gain depends on what you want to study, that is the object, the nature of the object, and the wavelength. So depending upon what your interests are, what your skills are that you already have, or what you can develop over a period of time, you can be any of these things. Okay, so you can study any individual objects, all that you have heard, or you can do all of them in that particular wavelength. So that is one kind of facility that you have in astronomy and astrophysics. But it is also true that many of the students here are from the engineering background. So when you are from the engineering background, the common notion is you have to get into IT sector and then campus placement, sit at the bench, and then go for an on-site project, and then that is one option. But if you are keen in astronomy, you can still digress into astronomy. Mechanical engineers, aerospace engineers, there is a lot of scope. When you are looking at this telescope, right? Even the small telescope needs a very sturdy mount that holds it, which comes from an engineer. Okay, you cannot expect a physicist to build a strong mount like that. They can design, they can give the math for it, they can give the physics for it, but you would still need an engineer to realize that idea into a product. So that is where engineers become very, very important. Structural engineers are needed, mechanical engineers are needed. Engineers are needed to understand how glasses work and take glasses from being glasses to telescope usable glasses. So apart from that, you have also seen that there are a lot of wires attached here. I mean, Akarsh was just commenting, too many wires are spoiling the life. They always create troubles. So you need people with electrical and electronics knowledge as well. So a lot of scope for electrical and electronics engineers also exists in the field of astronomy and astrophysics. So what you can do is you can finish your engineering in the course that you are doing and then take up projects or specialization in astronomy as an application. So electrical engineering for astronomy. How do you build radio transponders? How do you build antenna? How do you build communication systems? How do you integrate them? So all these things are basically is what is required in the professional sector from an engineer. So regardless of whether you are an engineer, whether you are a pure science student, the opportunities that exist for in the field of astronomy is umpteen. Finally, what if I'm a computer science interested guy, no, regardless of whether it is sciences or engineering, then definitely there is bigger scope for you guys, simply because wherever we go today, the basic idea is data analysis. So data, how you see them, how you analyze them, what you draw out of them, what you conclude out of them is very, very, very crucial. So you can pick up data analysis, and there is a huge scope for data analysis in astronomy and astrophysics, which is also a very key position that you can explore. So depending upon your interest levels, you can pick domains, you can pick streams. And I'm sure there might be one or two students who are sitting here and saying, sir, all this is beautiful, but I'm very much interested in theory only. Definitely, astronomy also has enough opportunities for you. Theoretical astrophysics is one of the most crucial aspects to devise an idea, to come up with an idea of understanding lot of physics and math of different kinds of objects. So theoretical physicist is also equally important. And yeah, that is brief about how you can quickly go from being an amateur to professional. Of course, this typically is an hour discussion that I do when I go for my lecture, but given the fact that we are at the fag end of the day, I thought I'll not have any PPTs or I'll not have a long discussion. Of course, if you have any questions or queries, I'm available. And if you have the BAS poster, it's my number that is there. So you can reach out to me any point of time. We can have discussion, or you can reach out to anyone in BAS and they will be able to direct you to me also, or I can respond. So I think I'll just stop here and say that be it amateur domain or a professional domain, astronomy and astrophysics is one of the most upcoming fields in India as well as across the globe. I hope all of you are aware that just a couple of days ago, the Indian machineries, I mean, when I say machinery, all the bodies of the government, they have approved a huge sanction for space programs in India, which primarily benefits engineers and also astronomers. Okay, so all the students out there, you have a huge industry that is wide open and calling for you. So the faster you brace yourself, upskill yourself and are ready, I think all of you have a wonderful opportunity there. So with this, let me wish all of you all the best, hoping that you will continue the journey that you started as an amateur astronomer today. And hopefully some of you will digress or progress, whatever you want to call it, from being an amateur to professional. So all the best to all of you, and thank you for listening. So just go ahead. And I also took up the responsibility of giving vote of thanks because, like I said, I can take all the credits for all the efforts that they have done. So let me start by thanking very quickly Dr. Asha Rajiv, who is the director of the campus, for readily agreeing when we put forth this idea in front of her. There was a little bit of to and fro between me and Sudash that was happening, and then suddenly we said, okay, this is time that we go ahead, and we went ahead, and within a very, very short notice, we were able to design and execute and get necessary approvals because of Dr. Asha Rajiv. I would like to thank her in her absence. I would also like to thank Dr. Sudhakar Reddy, the HOD of the department, who readily agreed and said, this is an event that will benefit everybody, and
we should just go ahead and do it in spite of this being a third Saturday, which is holiday for us. So thank you, sir, for your support and encouragement. I would also like to thank all the faculties of the department who have supported in bringing students and sharing content everywhere, and also Dr. Shashank for staying with us throughout. Of course, I have to thank all the BAS members, the core committee, whoever is there, including Keerthi, Akarsh, Sudash, Nandan, Shashi. So many people are there as core team of this workshop. So I would like to thank all of them for curating this wonderful event and executing it so very well without any flaws. So thank you all for doing this wonderful thing. And I would also like to thank all the resource persons. They have taken a lot of time. Like I told in the morning, I know they have run through the PPTs, they have modified, changed. Multiple dry runs have happened, online, offline, everywhere. Discussions have happened. And they have put in a lot of time and efforts in bringing the content to you. So congratulations and thanks to all the resource persons who are present today. Of course, there are a lot of volunteers from BAS and JAIN. Thank you. Most of them are my students at JAIN. So thank you guys. And I hope this was beneficial. Of course, the participants are most important aspect of any workshop or any event. So all of you took your Saturday off, spent entire day with us. I hope the session was interesting and food was good enough that it kept your interest alive. Thank you for taking time off, coming and attending these wonderful workshops, to each one of you present here. I would also like to place on record a special thanks to our facility manager, Mr. Ramesh, and his entire team for making sure all the logistical things are in place. The water, food, this, everything functioning is perfectly fine. And also Mr. Saptagiri, who is taking wonderful pics. Please watch out for Jain University official handles. All the photographs will be uploaded there, and BAS also will be tagged, so you can keep following them as well on the socials. You will get updates there as well. And at last, let me thank 1947 for giving wonderful lunch, and our regular vendor who has sent us very hot good samosas, which is waiting for you. Yeah. So now there is some more motivation. So thank you all. Before we conclude, there is a QR code that is being displayed for your feedback. Your feedback is very, very crucial. So we request you to please fill in the feedback and make sure it is there. If you can be please seated for 2 more minutes, we will just felicitate the speakers, whoever were present today. So let me call out the names of the speakers, and I request all of you to quickly come and collect a small token of gratitude from the Jain University side. Shashi, where is Shashi? Okay, so let me start with Nandan. I would call Dr. Sudhakar Reddy to please give away the prizes. Sir. 20 minutes. Varun, Gautham, Ranjit, Vaishnavi, Vinay, Snehith, sir. Raghul, Subhendu, He's not here. Okay. Of course, Akarsh. And also Keerthi.
Everybody done, right? Everybody done.
And Pramod. So thank you all. Like I said, this is just a small token of gratitude from our side. I hope you guys like it. Thank you guys. We'll meet here again for another event on astronomy and amateur astronomy. And please make sure you fill the feedback forms, because each and every individual feedback we do go through and we make changes. Some of you, if you have attended our previous workshop, you will definitely know we have worked on the feedback that you gave and we have improved. So we want to improve it even more in the coming days. So thank you all for joining us. Please have your coffee, tea, snacks, and please go back to the counters where you signed in the morning for getting your certificates. So there are two separate counters for JAIN SOS students and non-JAIN participants. So please go to the same counters where you signed in the morning and collect your certificates without fail. Thank you guys. See you.
Subhendu was not here. Snehith will collect Subhendu's.
Yeah. You can just bring one.
Thank you. I'll take my batteries.
ಇರ್ಲಿ ಬಿಡು. ಸರ್ ತಗೊಂಡಿದ್ದಾರೆ, ಕಾಪಿ ಮಾಡ್ಕೊಂಡ್ಬಿಡೋಣ ಅಷ್ಟೇ. ಹಾ ಸರ್, ಇದೊಂದು ನಮ್ಮ ಫೋಟೋಗ್ರಾಫರ್ ಕೊಟ್ಬಿಡಿ ಸರ್. ಇಲ್ಲಿ ಕಾಪಿ ಅಂಡ್ ಯಾಕೆಂದ್ರೆ ಇದಕ್ಕೆ ಹೋಗ್ಬೇಕು ನಮ್ಗೆ ರಿಪೋರ್ಟ್ಸ್ಗೆ. ಹಾ ಹಾ ಈಗ ಪ್ರೈಸ್ ಡಿಸ್ಟ್ರಿಬ್ಯೂಷನ್.